So first of all, this is the amazing team that organized this workshop. So thank you for all the organizers, also the ones that are not here. We would like to also thank the sponsors for this workshop. We're hosting a lunch today after the workshop. There is a limited number of places, so we hope that you will be able to get there. So the goal of this workshop is to bring together people from different communities. We have here people from graphics, vision, HCI, and also some artists, and to think together about new ideas of how to promote the tools that we have for Gen AI.
Yeah, so I guess this workshop has a pretty nice history. It was started in 2021, and I think we have had many attendees so far, 50 keynotes. The previous one was in CVPR 2025 in Nashville. And yeah, this is the first time SIGGRAPH is hosting workshops in general, and I think SIGGRAPH is a great venue for the goal of this workshop. And yeah, thank you for attending this workshop. And this is our schedule for today.
Yeah, so this is our schedule. We're going to have 2 sessions. In each session, we're going to have 3 talks, followed by a panel discussion. So also, if you want to ask our speakers some questions, feel free to scan this QR code and upload some questions. Yeah, so we'll give you a few seconds to scan it if you would like.
You'll bring it back up.
Yeah, we'll bring it up again. Okay, so let's begin. So our first speaker is going to be Mira from Adobe.
Good morning, everybody. Thank you so much for waking up so early on the last day of SIGGRAPH. I know I'm feeling a little bit tired. I bet all of you are maybe feeling a little bit tired, hopefully super energized. My name is Mira Dontcheva, and I work at Adobe Research. I lead a team of HCI researchers, and we work on audio and video, and we're just a small bit of Adobe Research. Adobe Research is much bigger, focuses on a lot of different types of research, from creative tools to documents to marketing applications. And our focus is to really make authoring video and audio fun, and to give creators a sense of ownership and control. And so a lot of what I'll talk about today is about interaction and what are the different ways we can give creators control. So when we think about the world, we divide it into 2 buckets, and I realize this is an oversimplification, but we tend to think about it as people who have assets and want to tell a story with those assets, and people who have a story or idea and don't have assets to create them. And a lot of the work my team's been doing has been on the left. I have a bunch of things I want to tell my story. But as generative models are getting better and better, we're starting to think about what are the tools that we can use for generative models, and what are the relationships between those we use for captured content and those we use for generated content. And what happens when people want to do both, when they want to use captured and generated content? Are there connections between these tools? Are these semantic tools similar, different, perhaps the same? How do we bridge these worlds for our users? We're not the only ones doing this research. Perhaps some of you in the audience are doing this work. And I just wanted to call out Professor Maneesh, who is really a pioneer in this area and has inspired a lot of our research. And he and his students have really been doing great work in this space for over a decade. And so I'm honored to share the stage with Maneesh today, and I look forward to hearing your talk right after. So my team, when we think about all these new generative tools and how they should and how they can really enhance creative workflows, we anchor our work in the workflow. How do creators work? How do they create? And if you talk to creators, you'll learn that everyone does things slightly differently. It turns out there is no one way. That's what they keep telling us. Well, I do it this way, and they do it that way, which makes it hard if you're a computer scientist and you want to build that great tool that can work for everyone. And so for the purposes of this talk, we're just going to kind of talk about the beginning, middle, and end very loosely. And my claim is that these generative technologies and tools can help throughout this process. They can help in the beginning when people are just getting started and they have a pile of footage and want to put it all together and get going and figure out what they have. In the middle, when they have something, but it's not quite right, they want to iterate. Maybe it needs to be more flashy, faster. Maybe the music's not quite right. And then at the end, when they have something they really like, but now they need to promote it and they need to push it out to social channels and maybe make little ads and little short things that will present the essence or hook people to come watch it. So I hope, so over the next 15 minutes or so, I'll share a bunch of tools we've tried in this space. And I hope that all of you saw a great talk just earlier this week at SIGGRAPH. On Monday, Marcelo Sandoval Castaneda presented Edit Duet, which is a system that uses 2 agents to generate sequences of B-roll, which help to make a video more interesting, more engaging. And so that's a great step forward. We now can take raw footage and make sequences that are pretty effective, higher quality, but how do users interact with it? That system presents pretty automated approach, maybe with a prompt. And so one thing we could do is look to systems like Bscript, which is a system that came before generative AI that explored how do we interactively help users find good places in a video to place B-roll, and then how do we let them look for alternatives. And so perhaps we can marry these worlds where one system suggests sequences and then another one helps you iteratively explore alternatives. I won't show you details. I'm going to just point you to these papers and ask you to go look for more if it's interesting. Instead, I'll tell you a little bit more about a system that focuses on the end of the process. And this is a research we started a couple of years ago, and the goal here was to help people make teasers. Now, how many of you use social media? Almost all. How many of you have seen little teasers for your favorite podcasts? Maybe some of you, all of you. So these, it turns out, are very common. Today, there are actually a number of production tools out there that do them. And if you haven't seen one, this is what they look like. And I'm gonna try this audio. We'll see if it plays. Doesn't play, it's okay. You get the gist of it, which is that you have a long video and now you want to create this teaser that gives you the essence, gets you excited, wants you to go watch this video and learn more. To do these often requires hours, and creators really, want them and they want to be done with them. And so since we've done this research, there's been a number of products that have done this. And what's interesting is that they all focus very much on automation. So you give them your long video and out come 10, 20, 30 little clips that you can then share. And so in the research, we said, well, let's take a look at an interactive experience. What might that look like? And so here I'll show you kind of the steps of an interactive experience that also gets you to teasers. So this is the first screen of Pod Reels. This is a plugin for Premiere. And here users can describe things like how long they want their target teaser to be, whether it should just be a guest or just the host or both, and the kinds of teaser they want, informational, funny. And then of course they can optionally also add keywords. We suggest keywords based on the content in the video. So that's step one, telling the system, here's what I want. And many of the production tools also offer these types of inputs. The next stage, review. Here are a bunch of ideas. Here's what a catchy title might be. Here is who's in it. And so that is similar, again, to what you see in these automated solutions. But then the next stage is the refine. And here's where this tool kind of took a detour from what you see in many of these tools today. And in this stage, we said, well, what would it look like to have a different interface for refining? Not just dumping you in the timeline where you have to deal with clips, but instead letting you work with sentences. So if your little teaser has these 3 sentences in it, but you only want to use the first and the third, how can we make it easy to remove parts of it? Can we do this in a more meaningful way, especially for something like podcasts where it's all about talking? And not only that, we often know that making these teasers requires multiple clips, maybe some from earlier to set context, some from later. And so we gave users more controls to do that by showing them what came before and after, and then allowing them to search for additional content that they could then add to the teaser. And so this is a refined stage that lets you refine these podcast teasers. We additionally helped with some visual things like letting users add different reaction shots when they were jump cuts, and then also add music, and then change aspect ratio, add branding and captions. So I'm going to play this for you, but I guess I don't know how to make the audio play, so I'll just play it for you. Oh, maybe, or you can. Oh, it requires a cable, of course. That would make sense. Let's try it again. Sorry. Let's not blow your ears. Let's try. Okay.
Something they can't really do anything about.
So this is the output that came from one of our users today using the system.
More of anxiety as being a habit. Is that correct?
Yes, and this is what blew me away.
So you're seeing, different pieces of the conversation coming together. So what do people think about this? What do they think about the idea of recommending short clips broadly? They loved it. Even though, here's what one user said, even though I had a general idea of what kinds of clips I wanted, manually looking for them was very tired. It seemed impossible to find the perfect clip that checked all my boxes at once. So I was really relieved when the system was able to conduct the search for me. And this is actually just speaks to why we see these products proliferating in the space, is that there's value in searching through this long space and suggesting to users. But what about the refinement? Do users really want to refine, or are they okay with fully automated results? And so here we see the before and after context sentences on the refine page were very helpful. Sometimes it's difficult to get the clip's content as it ends a bit too early. However, these surrounding sentences made it very feasible for me to understand and provide context for the audience. And then another participant said, the AI software I tried before doesn't give me that freedom of customizing. They're like, this is what it is, take it or leave it. Whereas this, Reels, gives you the ability to explore possible options and mix and match without making it overly complicated. So really want to emphasize that first, recommending these teaser clips is a huge win, it's faster and easier, but this customization and refinement was super helpful and necessary, and we have to be looking at different ways to do this beyond just traditional timeline UIs. All right, so back to our map of the creative process. So I showed you pod reels, and as we've been experimenting with more and more of these generative models and how they can help us work with video more easily, we've gotten to this point where we can now generate many, many variations, right? I can get many, many teasers for my podcast, but now I need to compare them. I need to be able to tell, well, which one is the best one? And where does the content for this one come from? And what about this where? Are they overlapping in any way? And so that is what we set out to look at with a system called Video Diff, which we started last year. And in this work, instead of having one timeline and individual, looking at one project at a time, we said, what if you had experience where you could compare potential timelines? So I'm going to play this for you. And so here you see the system given a prompt has generated a bunch of different variations. And now the user can select which ones they like, go to the top. You see here, I'm going to just pause this. You have two variations at the top, and they have these bars, these visualization bars at the top that tell you, I wonder if I can do this. Oh, I can't, look at it. It can tell you where the different sections are of these videos. And from these overview, you can tell that both of these are about the same duration, about 2 minutes. They each have 6 sections, but you can't really tell if they're similar or different. You can tell maybe a little bit from the visuals, but we also built a visualization that then, let's see if I can play this, allows you to switch from this view, which is like this edited view. Oh boy. Oh, that's great. All right, well, give me a moment as we open up PowerPoint again. Exciting.
Microsoft Bud.
I'm sorry?
The Microsoft Bud.
That's right. I'm sure I'm the only one who has experienced those bugs.
2025.
I always joke that we're working on AI, but I still can't do simple things like video conferencing or printing things. So, you know, maybe one day we'll solve these problems. So let's see, let's jump ahead. Here we go. Thank you for bearing with me. All right. Let's try this again. All right. So back to this view, you get a bunch of variations, and the question is, how do we compare them? What are different ways to do that? And we explored a bunch of different techniques. One of them, as you see here, is this idea that we can tell you what the sections of the video are, and then we can switch you to a different view, which we call the source timeline view, which shows you where this content comes from in the original video. So it kind of expands this timeline and then gives you these solid bars showing you, oh, for this top one, it comes from the beginning, and for the second one, it comes from somewhere in the middle. So that's like one way you can get a sense, but we also created this transcript view where you can get into the details and you can see, oh, okay, on the left, you know, this section is coming from up here, and this other section is from down here. So this is a quick overview of some of the things we experimented with. What did people think about it? Well, what we heard was it's really useful to explore multiple paths at once and be able to switch between them easily. So people hadn't really experienced this idea of having multiple variations. They found complementary roles of these timeline views that give you a sense for how things work in time, and these transcript views that really focus on what people are saying. And then last, because I can quickly skim the differences with visuals and zoom out, the same amount of suggestions don't feel overwhelming. And I think that's one of the challenges with some of these experiences is how do we provide sufficient information to get an overview of what's happening without overwhelming users. All right, so I have one last system that I wanted to share with you, which is at the beginning of the process. This is Chunky Edit. And what this system does is it looks at interview footage, and it says, well, how can we help people process interview footage so they can get going with it easier or get going with it faster? And it addresses this very first part of the process where you have a bunch of footage, a bunch of interview footage from one or more people, and you want to create a paper edit or a string out of this content so you can see all the things that you have in an organized way. And there are many different approaches, automatic, hybrid, and manual. People do a mix of these. And in this system, what we did was look at, okay, if we were to give people some automation that helps automatically segment these videos by question and then automatically group them by topic, how does that help with this paper edit process? And this is the interface you see here. We have the video, the questions are in gray with the answers that each customer gave, and then the topics are here on the right, or the content group by topic. And already even this part, being able to color code and segment questions and answers was already super helpful, but having this topic segmentation on the right by color was really, oh, I missed the video for you guys, was even more helpful. There you see these different topics. And so as you can imagine, this is just addressing this first part of the process. How do I take content and then structure it in a way that makes it easier for me to work with? And then users can then go into the regular video editors and continue doing editing. One thing that I found particularly exciting about this and what customers said when we asked them about it is we were excited to hear that this was helpful. It really assisted them with the rough cut creation. If we could already generate that raw string out, that I'm already saving myself a few hours at this point. So saving hours, always a good thing. Chunky Edit is definitely a good starting place, is what another customer said. But the part that I found perhaps most exciting is that people said, this is not just going to help me do my work faster, but it also helps me communicate with others. And I think that's something that we often don't think about, is how do the tools we build help us communicate with others? Because we're not the only ones often working on this. So what the one user said, the paper edit seems like actually it would streamline the process for me a little bit, or at least put it in a way that I could send to clients. And another one said, if I was providing all this footage to a producer and they don't really have familiarity with an editing program, at least they would be able to play things out themselves. And that's something we've definitely heard is people who aren't editors often need to make decisions about content, and giving them simpler UIs that are more semantically driven helps with that process. And so I'll close here. I hope I've convinced you that creators love suggestions, that they want the power to customize. We need creative tools to support working with an alternative as more and more generative tools enter our workflows, and that creating often involves communicating with others, with communities, with teams, and so we need to be working on those tools as well. Thank you.
Do we switch? So we have a couple of minutes for questions, if anyone wants to ask.
Is this already commercially available?
Is which?
Will be a software you introduce.
I showed you a few different systems. Some of them are available, but not all of them.
Yeah, okay, yeah.
Would you make this part of the Mira?
Yeah, so they're definitely, like Chunky Edit, what I just showed, if that was the one you were asking about, would be a very natural fit for Premiere Pro, where people have a lot of footage and are coming in. These are professional editors, so they're working with lots and lots of hours. So that would be a natural place. But we think these ideas could make sense for others too, right? Doesn't have to be just, perhaps, yeah.
What programs would involve the overall biggest efficiency?
It's a really good question. It's a very hard one to answer because it depends for who, right? Who are we talking about? So if we look at podcast creators, they're not editing, they're not doing string outs, they're not editing, they'll start with their podcast, they'll usually do a little bit of cleanup. And so for them, pod reels are this like social shorts kind of creation, huge efficiency gains because they don't have to go and look for how to make it. If you're talking about people who are creating, some kind of explainer video, then for them, I think having tools that help them deal with the raw footage, help them suggest which B-roll to include, those can be also big efficiency gains.
Okay, so let's thank Mira again. And then our next speaker is going to be Maneesh Agrawala, a professor from Stanford. Thank you, Maneesh.
Okay, great. Let's see, I'm going to turn off the captions. Is that okay? Good. All right, so thank you. I am Maneesh Agrawala from Stanford and from Roblox. And in my group, we have been interested for a while in developing better generative AI tools for visual content creation. We've done a lot of work in this space, but I'm really excited about it. And one of the things that I want to convince you of today is that making visual content is all about making decisions, right? An author has to make lots and lots of decisions at various levels of abstraction. So let's think a little bit about how a content author creates high quality content. I think that authors are really doing two main things all the time. They're exploring the space of possible designs, often in a pretty controlled manner. They're trying out various options, for the designs. And second, they're refining the design, usually starting with course structure and then adding in detail iteratively. And along the way, they're making all kinds of decisions. They're deciding what to leave in, what to take out, and what to try next. So this is true of creating text documents. Think about any text document that you've written. Maybe it's a paper, maybe it's something else. We're always starting by exploring the structure, right? And then we do multiple editing iterations that improve and refine the document towards an end goal. And editing the text in this way often improves it pretty significantly. And this is, of course, true of drawing and sketching. It goes by quickly, but this artist redraws parts of the image, exploring different designs for different parts of it, for the lower torso and the body. And she starts by drawing the overall pose, the contours of the major body parts, the head, the torso, and so on. And then she adds in the details. So she's exploring and refining iteratively. And this is, of course, true in filmmaking. We saw some of this in Mira's talk, but editing video is a process of exploring the raw footage, finding the pieces that you want to put into the film, assembling them into a rough cut, and then carefully refining each edit into the final form. So all of these processes kind of follow the same general approach. We explore the design space, and we iteratively refine it, and we're often jumping between these two steps. Now, the promise of generative AI tools is that they will facilitate both exploration and iteration. Here is, I think, the first magazine cover that was generated using a text-to-image diffusion model, and it was made by the artist Kuan-Chieh, who is just an amazing artist. You should check out her work online if you haven't. The cover itself claims that it took about 20 seconds to make this image, but of course, that's untrue. So she made this TikTok video describing her process. Let's see what she says about it.
Then I got to work, and I used DALL-E to generate options, but none of them felt quite right. This one, for example, was too boxy. Each time I adjusted my prompt over and over again, refining it to try to get the right image. And after many, many hours of trying hundreds of prompts, finally figured out the right one. It was a wide-angle shot from below of a female astronaut with an athletic feminine body walking with swagger towards camera on Mars in an infinite universe. Synthwave digital art. Here's how it turned out.
Okay, so what did she say? She said she was iteratively refining the prompt, but I'm not really sure that it was an iterative refinement process. I think with generative AI today, it's really much more of a trial and error process. You're exploring the design space, but in a fairly uncontrolled manner. And this is why, as she said, it took her many, many hours iterating through hundreds of prompts to find this one. Right? It really is a long trial and error process. So the reality of generative AI tools today is that they are terrible collaborators because they force this kind of iterative trial and error. And I've argued at length about why generative AI are terrible interfaces and why I think this kind of iterative trial and error is so frustrating. And it's because users don't have a predictive conceptual model for the generative AI. A conceptual model that predicts how the input prompt maps onto the output image. So the lack of this predictive model forces users to try a prompt, get a result, and then adjust the prompt, often in somewhat random ways, hoping and praying that they will get to a useful result. And I'm sure that many of us in this room have experienced this kind of frustration using text-to-image generators, right? You start with something, you're hoping for a nice result, but you have to spend a while playing around with a prompt, trying to get it to do what you want. And this is extremely frustrating. Now, one of the things that this means for us as AI tool creators is that it's our job to provide interfaces that let users predict the mappings between input prompts and outputs. But this is challenging because no one, and especially not us, the tool builders, even not us, the tool builders, have a good sense for what these neural networks are doing under the hood. And so, so it's very difficult to provide this kind of predictive model. And so short of providing this kind of predictive conceptual model, what can we do? Well, we've been thinking a lot about the properties of effective AI tools. And we've been inspired by colleagues in HCI who have studied the effectiveness of direct manipulation tools. And so I think there are three key properties of AI tools that can make them more effective. First, to support controlled exploration of the design space, we want a kind of consistency. We want to maintain identifiable structure across AI operations. So in this drawing example, each stroke is a kind of drawing operation. It's an individual action. And each one changes the image a little bit, but the overall image structure remains very similar from stroke to stroke. And that kind of consistency of the image is very, very important. It supports a kind of controlled exploration. And so I think this is important. Next, to support iterative refinement, we want hierarchical decomposition. Here, well, we want to break complex workflows into sequences of simpler operations. And here, the artist, as we've seen, draws the major parts of the body, the spatial layout, the pose, and then adds in details afterwards. So she's refining it. And then finally, to support exploration of the design space, we also want rapid do and undo. Each stroke here can be executed very, very quickly, but you can just as easily pull out the eraser and erase a stroke and then redraw it. And we've known for a long time in interface design that speed and undo are extremely critical. And so we've built, we've put in a lot of effort, even in the realm of AI, to speed up our inference techniques, to build things like undo stacks. And this is all very, very useful. And in fact, today, I won't spend much time talking about this third point. I think there are some new opportunities in this space on even this third step with generative AI. If you were here at the talk on Monday that I gave at another workshop, I talked a little bit more about this, so check that out. But for today, I'm going to focus on the first 2 points. Okay, so let's talk about consistency. And one example of this is my graduate student Lumen Zhang's work on ControlNet. ControlNet is all about consistency, specifically spatial consistency. And it's a model that's designed in the context of text-to-image generators. And you know, as we've talked about, image generators don't maintain a lot of consistency from prompt to prompt. At least at the time when we put out ControlNet, that was a big issue. So you write a prompt, you change one word of the prompt, and you get a completely different image. So, so we wanted to address spatial consistency. And with ControlNet, the user provides this kind of conditioning or control image. So in this case, edges or a human pose from OpenPose, and then you feed it through the ControlNet text-to-image generator, and you get these kinds of images that maintain the spatial consistency from image to image. So here at the top, we can get outdoor facades. Here we can get indoor facades. The global appearance is controllable a little bit through the text prompt, right? But the spatial consistency remains very, very locked in, and this is proven to be very, very useful to artists. Okay, so more recently, in fact, last year at SIGGRAPH, Lumen showed this work on generating foreground and background images together using generative AI in a very, very consistent way. So the results here are generated from the text prompt alone, the text prompt that's shown at the top of the image. But instead of generating just a single image, we obtain a background layer as well as a consistent foreground layer that can then be alpha blended together to produce the images at the top. And this supports a kind of workflow that many, many artists use in tools like Photoshop to build up layers and put an image together. The key idea of this work on layer diffusion is to train an encoder for the foreground alpha channel into latent offset vectors that work in the latent space of stable diffusion, our text-to-image generator. And I bring this up because it's a really, really key idea. Because critically, we can add these latent offsets to the latent representation of the RGB foreground. And we can then decode the RGB using the original stable diffusion decoder. All right, so we're just adding this little offset in latent space, and we can still use the frozen original decoder to get back the RGB. But also, we have we've also trained up a separate decoder that can decode this adjusted latent to get back both the RGB and the alpha channel. Okay, and in a way, the encoder, this latent offset encoder, is kind of hiding the alpha channel information in the latent space of stable diffusion. And I just wanted to bring this up because I think this is a powerful idea, and we've just explored a little bit of it. I think there's more to do here with hiding information in latent space. Okay, on to some results. So we can start with a foreground image with this tool and a text prompt, and we can generate a background that is very, very consistent in lighting and other factors. It fits with the foreground. And by choosing a different seed, we can get a different background that, again, is very, very consistent. Similarly, we can start with a background image and a prompt and generate a foreground. And the system, the layer diffusion model, is choosing how to arrange these foreground elements so that the dog looks like it's sitting on the sofa, right? And the woman is sitting on the bench appropriately. And we can change the animal or the person in the same way. So these are some of the things we can do with this layer diffusion work. All right, last year we also started looking into the problem of relighting images. So here's an image of a person standing outside, and the pose is really nice, but I want to see what she might look like if she were in a room being lit by sunlight streaming in through a window. And so we developed a tool called IC Light, which relights the foreground object and then composites it onto a background that is based on the prompt and produces images that look like this. Okay, so very, very consistent lighting. And the interface looks like this. So you start with your input image up here, you extract out the foreground, then you use the prompt to generate a background image. And this time, the IC Light model is relighting the foreground to match the background lighting. And we can do that with lots of different prompts and background images. So we can get all these different things. Now, the key constraint in IC Light is based on the physics of global illumination. And the paper shows how we can incorporate this constraint into a loss function with our image generation diffusion model. So more details are there. One of the cool things is that we released this model and people incorporated it into Comfy UI and started exploring how they might use this kind of consistency in moving lights around. Now, nothing in the model tries to maintain this consistency, but if you look at the face, it's fairly consistent as we're moving around the light source. And so that was kind of cool. last thing I want to talk about is hierarchical decomposition and how we might support that. And I want to go back a little bit to thinking about how we work with AI today. So often what we're doing is we're taking a prompt, it might be text, it might be another modality, feeding it to AI and generating a result. And that's great when it's the result that we want, but often there are little problems with the result, and so we have to go back and adjust the prompt. Now, there is an alternative approach that I think is really, really exciting. And the idea is you give a prompt that AI, instead of generating the final result, generates a program. And then you execute the program to generate your final result. Okay? And you might ask, well, why should I go through the trouble of generating this program? Well, the program is a really nice representation. It takes the prompt, the high-level instruction, and it breaks it down into simpler steps. Okay? And as a user, you can come in and look at the output result, you can look at the program, and if there are problems in the output, you can come in and maybe manually debug the program, or you can provide feedback on the program and feed it back to the AI and ask it to regenerate. So this can be a really powerful loop, and I think can facilitate creation. Now, one piece of this that I think is incredibly exciting is to try and design the underlying code, the DSLs that one might use for the code that is output, because these languages are where we can kind of have an established common ground between the AI and the human users. The concepts that we're using to create the objects can be embedded in the languages that are being used. Okay, so I want to show you a last example. This is recent work. It was shown earlier this week by my grad student, Sharu. There. It's on motion graphics verification. So the idea here is that we start with a static SVG that makes this image, and in English text, in natural language text, we describe an animation that we want to produce. And we feed it to the AI, in this case an LLM, I think ChatGPT, and it generates a program that animates it, and then you run the program and you get this result. Okay, now if you look closely as a human at the resulting animation, you quickly see that it doesn't match the input prompt, right? The input prompt says move the orange circle above the rectangular shape, and it doesn't quite move above. It also says that we should rotate the letter H 90 degrees clockwise, and it does rotate 90 degrees clockwise, but it was supposed to happen at the same time as the translation of the orange circle. So in this work, what we developed is a underlying motion verification language. This is in first order logic. And the AI, just as it can generate a motion program, can also generate a verification program in our language. Here's what it looks like. So we are checking here that there's an object that is orange in a circle, that there's a rectangular object, that there's an H object, then we're checking that there's a motion of the orange circle, translating it all the way to the top of the rectangle, motion of the H, rotating clockwise, and that these two motions are happening simultaneously. We can then execute this verification program, get a report that looks like this, and we see from that report generated automatically that only parts of the specification in the prompt were met. We can feed that prompt back to the AI and generate a new version of the animation, and this time it properly is properly verified. It passes all of the tests. And we've done extensive tests with this. The upshot here is that without verification, you get about 58% of the prompts correct using this kind of LLM-based approach. With verification and correction iteration, you go up to 93%. So what I've shown you is that content creation really requires controlled exploration and iterative refinement. And today's tools, unfortunately, only support really uncontrolled trial and error. And so what I think we need for our tools to be effective is consistency, hierarchical decomposition, and also rapid do. There's some open opportunities. We need to think about how to build in consistency, how to break complex instructions into simpler ones, and then where we can speed up workflows. So I hope you'll join me in considering these problems. Thank you very much. These are the people that did the work, and more information.
I think we have time for just maybe one quick question.
So I actually am a big fan of your work. And every time when I see those papers, one of my mind is, how do you get those large data consistency data sets? Because, for example, like I see, like getting a person with different rank setting is actually incredibly difficult to find. So may I ask you how you actually get it?
Yeah, so we have, in the case of IC Light, we're generating the data. We're doing it in a synthetic way, and we can talk about it more offline, but we're essentially generating the equivalent of like stage data, but we can do it synthetically.
One more question regarding IC Light. Are there plans to train it on a newer model like Excel? Because it was trained on Stable Diffusion 1.5 and the resolution is quite low.
Yeah, we you know, we're thinking about it. It's a matter of, you know, trying to divide up our time between IC Light and other models that are developing. But would love to hear more about it.
Next, we have Polly from Huamin.
Also promise to not judge the amount of depth that I have. Well, let's move without speaking notes. All right. Hello, everyone. I'm giving this talk. All right. Everyone, I am Apolinário. You can call me Polly just because it's easier to pronounce. I build bespoke low and no-code tools in AI. I also do interactive art installations using AI, and I research the use of AI as a medium, which is what I'm going to talk about today. So the title of the talk is Generative AI as a Medium, Beyond AI as a Tool. So we had two amazing talks about AI tools and consistency, but here I'm going to talk about a little bit of history of some art mediums. The turntable DJ, you were not supposed to touch it, right? So when the turntables were invented, they were not supposed to be manipulated like that. They were actually made to be used in a live setting in a very controlled way. There was a rewind setting, but people started playing around with it, and they realized that if you move it in real time, you actually get the same amount of BPMs. So these early hip hop artists realized that they could play with these tools and use them in ways that were not designed by the creators, and they would do different things like this. There was this Japanese DJ that I don't have the notes to remember the name, unfortunately, but he basically said he was doing this in the streets of Tokyo in the 70s, and old and young people were getting mad at him because he was like touching touching it and scratching it, and it was not right. But this led to the revolution in hip hop, rap, and all of that. And then it was replaced by software. But the question remains, if software arrived first, right? So if we invented a software for DJing before turntables existed, would we have the scratch, the fade, the crossfade, or would we constrain people in a way that they would never be able to do this, right? So I think there is always a trade-off between constraints and free expression. There's this quote from Brian Eno that says, "Whatever you find weird, ugly, uncomfortable, and nasty about a new medium will surely become its signature." So this grainy film texture was seen as like something to get rid of. The 8-bit sounds of the NAS was seen as something that it was a limitation, like this beatbox that people wanted to express more high fidelity sounds. But Brian Eno also said that as soon as these limitations are overcome, people will want to look at them with awe, right? So, and that's what happened, right? Like we are looking at like this Polaroid photography, like their pixel art and 16 and 8 bits music is now made not because we have the limitations, but because we love it, right? And I believe that it's kind of what can happen with AI as well. Like we have this AI weird texture that we want to get rid of, but as soon as we got rid of it, there are some people that are like, oh, I missed the DALL-E 2 texture. It looked so nice. So AI as tools allow us to create things that already exist, and you can do it like, not harder, but like easier, better, faster, and stronger. And don't get me wrong, like AI is a great tool. So this is a new tool by Runway called Aleph that allows you to like see videos from different angles. It's like, AI is a great tool, like don't get me wrong, but I think we hear a lot about how AI is a great tool. But what I believe is that the pattern matching in the generative AI systems is very different than the pattern matching that we have in our own brains. So the way the systems kind of function and behave is very different from how we conceive reality, both in kind of text and language models, which then presents us with an opportunity. The opportunity is to discover the affordances of this new medium. So looking at this as a new structure, not only as a tool to recreate what already existed, and to create something new. So this is a system called Blue Tigers, is a recommendation system. Think of it as like the TikTok algorithm plugged into an image generation model. So it's kind of a text to image, but you remove the text component and you transverse the latent space based off of your own preference. So you first generate like 10 random images, and then based on what you like and you dislike, you transverse the latent space into kind of your own latent space. So on the right, you see that's my latent space after playing a little bit with the tool. And those are things I could never arrive at with prompting. Like how would I prompt something like that? And on the left, you can see also like exploring the latent space. In this case, is interpolating the clip space with some knobs in the real world, like a MIDI controller. In this spirit, I also wanted to show some early explorations that artists were doing. So with GANs, we had Mimo Acton doing this Gloomy Sunday, which is like this live real-time manipulation. And today we do like a real-time video to video, but this is being done since 2017 by artists. Also by Mimo, he created what is known to be the first film constructed fully on the latent space of the deep neural network. So with human input. So that from basically telling a story by transversing the latent space of again, back in 2018. Also, Mario Klingemann was before, like 3 years before OpenAI created the InstructGPT paper. did the first GPT instruction tuning for an art piece called Appropriate Response, where people would kneel. You see that she's kneeling. People would kneel in that kind of like pedestal and like do a prayer, and the AI would respond. And this was the first instruction tuning of GPT for an art project, right? So like we have like artists kind of leading kind of the imagination space, sometimes even ahead of its time. And then I will also show you, so those are all like kind of historical examples, but then considering the modern technologies we have today, I'll show you some of my work. So this is a real-time, it's called the glitch box. It's a real-time, like stream diffusion, so real-time stable diffusion running in this is South by Southwest London, where we had this installation. And we also have this live performance you can see on the background, the AI system, and she's a hair hanger, so you can see that she's hanging by her hair. So she's doing an artistic performance, and the visuals you see on the back, that style is also contributed by an artist. So we trained a lore on that artist's style with their consent, of course. And basically the idea of a collaboration between two artists, the artist that contributed the style with the artist that is doing the live performance, creates like this third thing that is greater than the sum of the parts, because it's a whole performance with the visuals. It's a collaboration between two artists that don't necessarily involve them meeting each other. So it's like kind of this protocol art. This is another tool that I created. It's called Parallel You, where you meet a version of yourself from a parallel universe. So combining a few different tools like real-time talking head avatars with voice cloning, and stable diffusion with IP adapter to generate myself into a different version, and then an LLM that to interact with the universe that I wrote. It leads to an interactive experience that is not possible without this tool. So it's kind of a new media because it's completely different than what there is. So yeah, let's use AI to build things that weren't possible before, to co-create with this Xeno pattern matching. And Xeno pattern matching is just a way to say that the way the system's pattern match is not the same as our brain, so maybe we can collaborate with them. And to learn these affordances without necessarily discarding the glitches. Sometimes the glitch is part of the process and is part of the creative, imaginative process. So to end, you see this is a pizza that you see on the screen. And that's a pizza with a negative prompt of food. This is something that you could create in 2022 with the clip-guided diffusion text-to-image systems. Because the negative prompt actually worked as a trying to pull the thing fully away. None of the modern systems can do it. You can go on any text-to-image generator of your choice that supports negative prompts and try that. It doesn't work. Like, it always makes a real pizza. But we had like a tool that became obsolete that still can do like this kind of like weird creative, like how could you represent a pizza without the concept of food? And it's kind of a weird lava puddle, but it's kind of cool. So yeah, thank you so much. There is in this QR code, you can read it. Basically, this PDF plus all the links in this talk are there. And there's also a few references like a book by Mao Tokui and a manifesto that me and some friends wrote. Thank you.
Thank you, Patty. We have time for a few questions.
Yeah, pretty cool work. I think there's a lot of commonalities with Manish's talk in the sense like the lack of controllability of Gen AI models, but is there any value on that property of the models, right? Like, have you ever been surprised by something that is being generated that you wouldn't explore, right? Like, is there any value on this randomness, right, for the creative process?
Yeah, I think so. I think that finding the balance between controllability that was very well explained by Maneesh, and some randomness as part of the process as entropy is very important. A lot of creative processes happen because there were some serendipity, some randomness, some encounter, including in science. A lot of like scientific discoveries have to do with serendipity and not only control over what you're gonna do next. So yeah, I believe that a lot, for example, this tool, this tool, for example, it allows for discoverability because, but it's still kind of a co-creation because you discover new things, but at the same time you have some control at least over what you like and what you don't like. So it's like a taste latent-based navigation, which is still random. You don't know what you're gonna get. So it's actually, we take this, you don't know what you're gonna get, which is a problem if you have a clear image in your head of what you want and then you're frustrated because you can't get it, like Maneesh said. But if you're actually not yet you don't fully know what you want yet and you want to explore things, then I think it becomes a positive thing. So there's always two sides.
Maybe I also have a question. So I think the pace in which we have new tools are emerging is like super fast. How do you manage the trade-off between going to the next model and exploring its capabilities, or just staying with another version that you already know how to control and maybe develop tools for that? So how do you manage this trade-off?
Yeah, great question. This trade-off is I think it depends on what the artist wants to do. Sometimes artists develop a certain craft where it's kind of independent of what if there's a new tool that does it better, it doesn't matter because what they're doing is not affected by better or quality and all of that because they developed a very structured process. So then they want to probably go deeper in the tools they already know. And for example, there are these tools from the text to image times that was called the VQ-GAN clip. There are artists that are still to this day working with those tools because they've crafted their space in there so specifically that's their kind of medium. And then I think that they're on the other end of the spectrum. I think artists can benefit from being at the very cutting edge even before it gets productized, meaning that because what happens is that all of us in this room do research that then sometimes we publish a paper, the code is open source, and then there's a demo on platforms like Hugging Face, and artists can actually benefit from it and use it in their own benefit way before a company like Adobe and others put it into a particular product or further the research and improve the user experience. So kind of like this rough first exploration. Even for example, IC Light that Maneesh has showed an example. There are demos of it on Hugging Face, and they were out the same day the paper was out. So you can go there right now and use it and play with it. So this is kind of like, I think those two ends. One is like really deepening into the tool, and the other is like being so bleeding edge that you can actually use research tools right when they're out instead of waiting until they get productized, which is super powerful for artists. And this bridge between research and artists should happen more, right? Where you have this, this dialogue. And I think, there are platforms, online platforms like Hugging Face, Replicate, FAO, and others could be a place for this dialogue to happen, where researchers put there and artists go there. And
Do you see any challenges with the technicality required of some artists, perhaps, to extend that type of relationship you were talking about between the developers, researchers, and the creators? And have you any thoughts on how to bridge that gap for people?
Yeah, so I think that's a huge, it's a very important question because sometimes a lot of artists wouldn't have the technical ability to like go on GitHub and reproduce a paper that someone has published. I think there's two alternatives. One is when the researcher themselves create a easy to use UI using tools like Radio or Streamlit. And that's become kind of a common process where the researcher, after the paper is published, create a demo, sometimes even in their own internal exploration, sometimes for the public usage. They will create a demo with a tool like Radio. And you can host these demos using a platform like Hugging Face. So that's one way, and then through that, the artists can collaborate. Another way is that some artists and some companies that employ artists, they have like kind of a creative technologist on team, and this person creates bespoke UIs for artists to play with these tools without being bound by existing traditional already made software. So a lot of filmmakers, especially, so filmmakers and some now interactive experience artists are using this tool. So I've worked, for example, with filmmakers that are like, yeah, they have a very specific workflow on their film where they want to do voice cloning and like kind of do a documentary with a person that already died, and essentially they want to recreate an avatar of the person and all that. So that they created a bespoke tool. So the filmmakers don't necessarily know how to code, but they have someone on the team that assembles these things together and create like just-in-time UI. So I think that's also something we'll see more and more. It's like this, not like rigid one-size-fits-all software, but like just-in-time UIs and UXs that people build and disassemble for particular projects, because it's actually simple to build these things with things like radio.
What's your wildest prediction?
Wildest, well, I think it's not that wild anymore. It was wilder when we started talking about it, but I think like kind of world models are gonna be huge. It's not that wild anymore, but like I think we're gonna basically open source world models. So like this navigable, playable, interactive models as a kind of a new media. Yeah, I don't know if I have a wilder thing than that. I think my wild prediction is maybe also a bit of a wishful thinking and and a bias that I have. But I think that the wildest prediction is not a new thing that is going to happen, but the fact that I think open source is going to catch up more and more with the closed source tooling. We already seen this gap narrow in things like text to image and text to video, and I think that yeah, we might see that. We're seeing that in LLMs as well. So I think it's my wildest prediction. I think would be to say that maybe in a couple of years, open source tools are like almost as good as the closed source tools. This gap narrowing and this commoditization would allow then for the flourishing of many new tools and exciting developments.
Okay, let's thank Polly again. So now we will have the panel. So Maneesh and Mira, please come to sit here. Polly also. Yes. So maybe let's start by a brief introduction of each of you, just to make sure that everyone is familiar with it.
All right, I can start. Hi, I am Polly. I just introduced myself in the talk, but if this is being recorded as a separate thing, I'll introduce myself again. I'm Apolinário. I work at Huamin Qu with machine learning for arts and creativity.
I'm Mira Dontcheva. I work at Adobe Research and I do HDI research in video and audio.
Hi, I'm Maneesh Agrawala. I work at Stanford University and also at Roblox. And mostly we're focused on control for generative AI tools.
So the first question is, can you share?
Could you use my?
Yeah.
Yeah. So the first question is, can you share a personal or professional journey creating generative AI tools?
We've been playing a lot with generative AI for video in particular, and I've been making videos of my kids' stories. So various funny things happen. If any of you are parents, I'm sure you relate that kids do funny things, and so I've been trying to make videos, generative videos of these funny stories. And recently I made one about my daughter who had a lot of anxiety about going to camp. And then I was really excited that I could do it at all because I'm not an artist. I have never done any film classes, so I'm really just learning as part of doing research. And so I made this video for her, and I was so excited about it. And then I showed it to her, and she was like, "Who is this?" She did not relate at all. So that was funny for me.
Yeah, I can share a personal story. So I have, my life was completely transformed because of this technologies. I was working at a startup that did like data science stuff, and I was using machine learning for like time series stuff. But then when I saw the DALL-E 1 blog post, that was January 2021, OpenAI put out that blog post showcasing that you could do text to image, which at the time it felt like it was like 5 to 10 years away, and they just kind of did it. I was like completely obsessed by it. It's like, how come you can do it? Later, then through these explorations, I realized that I have this characteristic called aphantasia, which is when you cannot produce internal images with your brain. Like if you close your eye and you think of something, no images appear. So I realized that with these tools, they could be my mind's eye. And that's the first tool I built. So I built this tool called Mind's Eye to do text to image in 2021 and 2022, before DALL-E 2 was released to the public and before Stable Diffusion was released as well. So it was like I think the first tool that aggregated all these modules. And yeah, and through that, I got into Hugging Face because they were like, well, yeah, this kind of use case for AI for art and creativity is growing in open source. Do you want to work with us? So yeah, it changed my life.
I don't know if it changed my life, but I will say that when the AI for image generation first came out, I was very, very skeptical that this would be useful in any way. And students would come and show me all the cool things that they made with it. And we were starting to see some papers that were doing some really cool things with it, but I just had no idea how I could really engage with generative models. And then we started thinking about the kinds of controls that artists might want, and we were just thinking about it, and Lumen essentially came to me one day and just showed me the beginnings of ControlNet, and it worked so incredibly well at maintaining spatial consistency that we realized that this might make image generation much more useful. And that was a big, big change for me in terms of thinking about the possibilities for using AI.
Maybe the next question is, where do you see clear gaps in current generative models and what they cannot address? And conversely, where might existing approaches be sufficient and maybe scaling just gets you more and more performance?
Yeah, so to me, I think one big gap is that I think a lot about interface design for generative AI as trying to build a conversation between a user and a machine, the way you might work together with another human if you were collaborating with them to make something. So that was really, that really resonated for me with Bodhi's talk, because I think there were elements of that in your talk. I think that there's some really deep questions about how we should arrange that communication. You know, I think it needs to be multimodal. We're starting to see some work in that direction. But I think more than multimodality, I think there's this question about how people can express their intention and how that intention is understood by the machine. So you know, how do you say what you want? Artists and many of us, everyday users, have a hard time expressing what it is they want and what it is they don't want. And so we've been thinking a lot about that.
Yeah, I guess I would just double down on what Maneesh said. I do think it's just so hard to use a lot of the generative AI tools today. And I think that's a huge question. How do we make them more usable? What was there today is maybe help, you know, you can scaffold things to help. A lot of people also adapt and learn. So working with some of the artists at Adobe, they prompt in ways that are insane to me, but they get amazing outputs. And so I think what's interesting is that we're trying to build systems that are going to be easier to communicate with, but at the same time, we humans are adapting to the systems. And so it's this dynamic system that that's very interesting in its own right.
Yeah, I think that when we scale, like, I think, for example, if we think about it by modality, right? Like if you think about image generation, right now we have very strong photorealistic models, but the more we scale up, they get better at photorealism. There's now like the ideogram character that can do zero-shot character customization without training LoRa's and things like that. However, I don't think scaling is only free in the sense that there were things like what I showed, like things like the way negative prompts worked when you had direct optimization don't work in the current way that you do diffusion models, because the CFG negative prompt is not really removing the concept from the image. And then there is some open research in that, but basically as we scaled and as we changed paradigm, we kind of lost one possibility. Also, the current text-to-image models are not super good with full like art styles in some ways. And some older models like Stable Diffusion 1.5 were actually better at that, even though it had other shortcomings. So I think that it's interesting that we don't like, it's not like a one directional improvement. Sometimes we lose things along the way. And then it's interesting that then they become research questions to how we bring them back. So yeah, I think that as we scale, we'll see maybe a combination of like more of those two things coexisting. And then as you asked also about what could be the next thing, I think as I answered on the talk, I think yeah, these video models that are controllable in real time and allow people to transverse them with the keyboard, like navigating around them, is not only coming, but like when Google released the Genie 3 or announced Genie 3, right, which is this navigation model, that's a world model, I put a tweet saying, oh, don't worry that in a couple months we're gonna have a bunch of open source alternatives to this, so don't worry that you don't have access. But then it wasn't a couple months. This week, 1 week after, we have three open source versions already of that, and I think it's only gonna get crazier.
Yeah, so maybe it connects to your question. Someone asked when you start a project, how do you, and maybe it's more relevant, for example, for Mira, who works in a company, whether to work with an open source model or a closed source. And maybe we can elaborate a bit on this question. How do you see, what do you think is going to happen at the end? Are the open source model are going to be as good as the closed source ones? I think Paul, you already answered. Feel free to elaborate.
how do we start? Since we are on the interaction side, we try to use whatever model is available to us that gives us the best output. We're just trying to kind of stay ahead as far ahead as possible, knowing that next week, next month, there could be another model that brings new capabilities. And so I would say we're pretty open, of course, considering the environment I'm in, we're in to use anything we can in research, and it's been pretty flexible and open. And I mean, it's hard to predict what will happen in the future. I think it would be wonderful to have, an open world where everyone can experiment and have flourishing of tools and experiences.
Yeah, we primarily use open source because that's what we have access to. But I will say that we treat the lack of access to lots of hardware and compute as a constraint in much of the research that we do. And that's been a useful constraint to us. So one of the constraints in developing ControlNet was that we wanted to make use of existing models that had been trained on lots and lots of images with, I don't know, it was like 600,000 GPU hours of the high-end GPUs. We had nowhere near that level of compute in my lab. So it was important to us that we had access to this open source model and that we could focus on fine-tuning it with far less data. And so that became a constraint, and that helped us design the architecture of ControlNet to make the best use of it if we could.
And just answering what happens in the end, I don't think there's an end. So this means this just keep happening. Basically, I think that right now it's a very interesting thing that all of us in this room know, but a lot of people in the general public doesn't know, that all the innovations that we're seeing in AI is not like a secret sauce that some of the big tech or the big companies have. It actually comes from research, comes from academia, sometimes it's research from the tech companies, but it's still open science and open research. And for example, Adobe Research, they open source a lot. Your lab open sources a lot. So being at Hugging Face, I can have a wide view of like who is open sourcing and what. And open sourcing is kind of sexy again. I would say I would be less confident of this answer like 1.5 years ago than I am today. Like today, Google is open sourcing again. OpenAI even has open source LLMs. And it's part of both the national strategy of the United States and China to do strong, powerful open source models. But I think there's no end where each will win. I think we'll keep seeing that as you mentioned, like the big labs will have way more compute and we'll do something in a different frontier that probably us in research labs or running things on our own laptops won't have access to, but then we'll have versions, open source versions that, and a lot of research that will try to use these constraints as a creative output to either equate or even surpass and then give ideas to the labs. And I think this feedback loop between open source and frontier labs is actually what fosters both the commercial side and the research. So I think that it's important that these labs don't forget that, and that if they think that they know everything and that they don't need research anymore and they keep growing, I think that's not a good outcome. If research thinks, oh, let's do everything open, we don't need them, sometimes there's not enough capital. So I think a combination of both is what's already happening, and I don't see that going away.
Another question is, what are your thoughts about like a winner-takes-all foundation model versus a bunch of small, specialized, domain-specific models? Do they have complementary uses, or do you think once the foundation models get, like a general purpose model gets really good, the role of domain-specific models like kind of keeps shrinking, or do you see a trade-off there?
I think every time someone bets against the bitter lesson, they get a bitter taste in their mouth. So I would say that never bet against big model getting better in things. But I don't think that means a winner takes all. because what we see and what I see also in the usage of models at Hugging Face is that people, the big models, like for example, there were a lot of research that were done in image editing space. And then once models like Flux Context or other editing models come out, it's kind of, oh, it can do everything. So now why? And then you create like this, what now and things like this. But on the other hand, we see that specific small models for specific use cases create different uses, for example, on speed. So you can do like, maybe the big model can do everything, but can it do everything in real time with low compute? Maybe not. So then you have an opportunity to then look into a smaller model that runs on device or and so on and so forth with like small models with very specific use cases. For example, even today, like literally 1 hour ago as we were having this talk, Google released a 350 million parameter, so a very tiny Gemma 3 that is like the best in its class. And it's already showing that you can fine tune it for particular use cases. So, and it runs on edge, it runs on your own device. And so I think that for a lot of, like the more you scale the models, the better they'll get. And I think we'll keep seeing that until some sort of, I don't know, until the log curve gets to looking too flat, maybe if that comes. But until then, I think we'll see that. But we'll also see, on the other hand, the smaller models having an edge on that particular use case. So I think it's always a couple things.
I agree.
You're in the best position to answer that.
And so maybe more questions from the audience.
Yeah, so I saw the title of the panel is AI beyond the tool, right? Like let's move like 30 years from now. Let's say AI now has agency and can actually generate videos and content that fool us, right? Like we don't know if this is real or not. Do you think there will be a market for like humanly made organic movies? Or will it be like, or nobody will care?
There already is. Yeah, there already is. There are already studios that say we don't use AI and we'll never use AI. And in the same way that Studio Ghibli says we won't use computer animation and we'll draw by hand. I think it's actually not. Yeah, I think it's not a. I think it's part of the world we're living in today, where I think there will be AI pioneering things, which is like using AI to do things that weren't possible without AI. There will be AI as a tool, which is like using AI to do things that you could already do, but easier, faster, cheaper, and stronger. And then there will be people that are like, I actually don't want to do AI. And it seems adversarial, right? Like if you look at some artists that talk about, I really don't like AI or whatever, it seems very adversarial with the people doing AI. But if we look into art history, like a lot of times, like this adversarial relationship between two kind of art movements are seen as one bigger package of like one bigger art movement in the past. So I think we in 30 years in the future, as you say, we can't know what will happen. But I think it's not impossible that this, like people saying, I don't want to use AI, I want to do things that AI cannot do, and I want to push boundaries in directions that AI is not in. And then people pushing the boundaries on the other direction and doing things with AI better and doing things that weren't possible without AI, doing things that if you don't have technical ability to do, AI allows you to do. And those things will retrofit each other, because the one side will be trying to create new things with AI, the other side will be like, I want to do things that AI is not capable. And it will look like an adversarial relationship, but it might be like one kind of movement if you look back from the future, maybe. Who knows?
I think just to add to this, I think we'll always have a desire to make, to record history and to archive our lives. And I think that is with us for the long run, like independent of what technologies exist. I think we as people want to document what is going on, and we want that to be capturing the reality rather than a perceived reality, or and I do think I guess I expect that will stay.
Yeah, I agree. I mean, I think there will always be interest in human stories and told from a human perspective. So a lot depends on what it means to have AI in 30 years.
And just to add one thing from your answer that I also thought is that if you think of language models, right? Let's say in 30 years they can do everything, but you still have the news of the next day that the model can never predict, right? I mean, unless we're thinking of a crazy sci-fi thing, it's like the newspaper of tomorrow is something that is not available to the AI because it's part of like the human experience in this planet, and maybe it's going to be a symbiotic human experience with other systems and intelligences that will be living with the machines in this gracious future or whatever. But I still think that even then we will still have the news of tomorrow that no model can predict, and we'll have stories that we want to tell.
And thank you very much. So let's thanks so we will now have a break, and we will start the second session at 10:45.
Yes. I think it's only for Zoom. Yeah.
The session is not being recorded.
I don't think so. Yeah.
Yeah, we don't have a direct line. I'm on it, but I think something which is we would love to, but because we would love to, for example, I think that the ICY thing it was like I think it was retreated. And then and then our community was curious on what happened. We didn't have an answer. Yeah, no, it's no worries, but let's stay in touch because I think that's I'd love to read more of these things, and I think the tools you guys build are also have a lot of potential to extrapolate.
Yeah, that's our
Conversation. You're here for Are you coming to lunch? I'm from Brazil. Was that your guy? No. There's so much they can, but the thing is, the way basically the model that I showed is not CFG. This was online optimization with guided search, guided AI. And then basically you could actually do the negative optimization, right? So it's like the one straight away. And on CFG, what they call negative, that's actually yeah, because on CFG, you like it's like the positive prompt and then the additional where you want to type first. And then yeah, CFG is active on CFG is active because like then you have like this idea of like, well, if you're straight in a way, let's go like low quality and stuff. Yeah. And it works in some ways, but because it's not really like it's not like semantically, the negative prompt is not really like pushing the noise into the negative direction when it's from the perspective. Like for example, the classic thing is like the watermark. It actually has more watermark. So for something like quality words, or so the but you can't get that level of control. Like I want absolutely no
yeah, that's like good. Actually, I guess now.
I don't think everyone has managed like basic negation as more classic even if yeah, but it's a full fight to think about. It's very right, just generate a bunch of action on what's the other yeah, and then
No, this video is
yeah, but I think that's there was a political sphere where you want to respond. But I think that's part of it. I also think this what you said it seems counterintuitive because they're like, why would they take one of the source and they wouldn't take it? But the thing is, a lot of their own portfolio depend on building tools. So not all companies are funded. And if you're not a foundation company, you have to invest money into AI or using an and sometimes going into APIs is not doesn't give you enough differentiation from others. But on top of it, so that's why a lot of these things are actually storing. Oh, yeah. But no. Most of them were like this. Oh, yeah. Yeah. Oh, okay. Also, the difference
We would like to continue, so please take a seat.
Oh, okay. Thanks. Yeah, well, it doesn't matter.
Welcome everybody, we're going to be starting in a couple of minutes.
Good. I'm from Taiwan. Okay. Yeah, so I have so. Oh wow. Okay. Thanks for the introduction. Yeah, it's my pleasure. Anytime. I'll give it talk after. So you know what I do. On the booth of the monster. Yeah, it's a so. They were VR experience.
All right, thank you all for joining to the second session of the day. So we're going to have 3 different speakers and a panel discussion, so similar format to the previous session for those of you that were here before. The first talk is going to be given by Niloy Mitra from Adobe and UCL. I'm excited to hear about what Niloy is going to talk about today. So take it away, Niloy.
Thanks very much for the introduction. It's a great pleasure to be here. Thanks for Roberts for organizing this. I think the joys of speaking in the second half of the session is all the good points have been already made, so I can just refer to that. While I was preparing, something, the news came in. So this is our Adobe video generator model, and you can now see the camera box. It just got live. This is what we have been working on in our team, which is adding camera control. The talk today is on something else, which is maybe not about the papers. I will talk about some papers, but also the journey and the lessons I learned, or at least the ones I think. So it's a very personal. I think some of you would agree, but I think most of you would not agree, but that's okay. That's part of creativity here. That's how this is a structure. I'll start with 2 stories. This is a structure you have seen, all of you. If you have gone there recently, you may have seen this part, which is this curved panel on the Eiffel Tower. And the story behind that you may not know, almost 20 years back, we presented a paper at SIGGRAPH on how to do optimization, geometric optimization with curved panels, so that you could reuse the molds that are used for making these glass panels. And this led to like 70% cost improvement, and that's what this company, RFR, got the contract because it's a significant improvement, and it resulted in this. So everyone is very happy. I was like, oh, it's a great success. I was still young at that point. I thought this is like height of my career. But then I found no one was using it beyond that. And that was a very important lesson. And the lesson is, you made a very hard problem easy for creatives, and these are architects, these are very high cost projects. As soon as you make it easy, as in clicking a button, it becomes useless for them, because it's not a difficult way to use it. And this is a lesson that I think is useful to learn. The other lesson is something that I've learned, and I've learned from some of the very seniors from here, which is about paper writing. I know I should not ask this question, but I should check. So a long time back, the style of writing paper used to be you start by writing the introduction. And that doesn't mean 2 days before the deadline. It means like 6 months before the deadline, even before you have the method. And the same applies when you do a figure. I used to do certain figures in my papers, in pipeline figures, even now I do. And I typically keep 1 or 2 days for a single figure for 2 weeks. This is a very slow process. And we talked about speed, etc. Personally, I like the slowness because it allows me to reflect on certain things. And there were many occasions while writing or drawing, these are equivalent in my experience, the work actually improved because I realized, oh, this is this other way of here. So slowing down the process has its beauty, but it doesn't mean slowing down the 100 letters I have to write by hand. That's not something I like. But there's certain process in the creative one where the slow thing, because we are slow as humans, like you know the fast and slow thinking group. Creating opportunities to do the slow thinking is important. So remember that, I will come to that. So let's talk about the creative process, and this is very high level. There's three main stages, and it's important, it came up in Mira's talk. First is this ideation phase, which is more an exploratory phase. You don't know what you're trying to do. I don't have an idea yet. Then it's called design iteration, a development when you fixate on an idea and you refine. This is this progressive part. And then there is a part which is feedback, which can be both yourself and coming from external sources, and how the design iterates. Life is not simple, so is creativity. It's very messy. All these are interconnected. It's not a linear process. But broadly, ideation has these bits where we want open-ended exploration. Then you refine or zone into a design, into a progressive one, and then you have a way to incorporate feedback. And of course, it doesn't have to be said in this audience. Creativity is very subjective. What I like, you would not like. That's something we need to. So I'll talk about one example of our recent works from each of these columns. So let's start with this ideation process. I expected Maneesh would talk about control net. I got that correct, which is where you have edges or normal maps, you get really, really good images. But this is not how artists usually work. They work with what is called blockouts. You sort of roughly conceptualize the space. You can also do the same for sketching, any of this, right? It's also storyboarding, it's different things. So last year we presented something which we call loose controls, which are also available on Hugging Face. And thanks Hugging Face for enabling this. This was one of those papers where when I gave the talk last year, unfortunately Shari couldn't get the visa. A majority of the room has already used it before they understood the paper because it wasn't Hugging Face, right? So the idea is you give very coarse blocking and you give some information like the text and out comes let you imagine, and out comes this output, right? So this is very good. What was the problem we were solving? So control net is amazing, and we've seen this. It takes in different control signals, you can see for this, which is maybe depth in this case, and it can give amazing images. The difficulty we realize in certain cases, creating this depth itself is as hard as a problem. And especially when I don't know what is this refinement phase. So what we came up with, what is the simplest thing you can do? And if you have followed some of our work, I like working with boxes because that's the simplest one. So we have cuboids. And then the idea is if you give these cuboids to control net or any of these, because it's trained with explicit signal, you get something like here, you see on the right, that's not the type of dolphins I was expecting. So what we enable is not this exact control, but what we call this loose control, and follow the paper, how we enable it. And we could draw on our experience in geometry processing, in scene inference, and doing abstraction. You come up essentially with this abstracted data on raw data, and you retrain this. And here's some output. So this is like a room scenario, the top being the abstracted room. The middle column is if you ask control net, which wasn't trained for this type of signals, but with our loose control, you get this. And something we don't talk about in the paper, but it is something I have in my mind, that this is the iterative process. Now you can do depth estimation on the last row and use that as your input for subsequent iteration. So I think this idea that we hit one button is done is just wrong. I think we have to do this iteration, and how to do it is an open challenge. There's also the type of consistency that Maneesh talked about. There's also consistency in appearance. Like once I've created this, if I move things around, you want things to be appearance consistent. If you followed the courses on diffusion we offered earlier this year, this week, or talked about it, and others. This is like you can do this with self-attention, cross-attention. These are understood right now. Okay, so that's ideation. Let's talk about the next part. I wanted, and I do want to do what's called defining a development. And again, I like to do a lot of things myself. So for our house, so those who had the opportunity to come to our house, the interior design I did. So I studied a lot myself of how the designers work. And this is like a rough flow you would get from a design workflow. And you'll see this the first column is first row is very interesting. The first time you go to any designer, in a room designer, they would ask you the question, how do you want to use the room? So it starts with, then the budget of course comes in, but first is, how do I use the space? This is so important, right? This is the function aspect of it. And we presented this type of thing earlier on, which is the text-based room generation. And the idea is, if you give so this was 4.0, GPT 4.0, you ask it to design a room, you ask it to design a layout, it would design this, which you can see functionally many things are wrong. It does a lot better when you ask it to design, give an image. And I thought our project is killed as soon as I saw this. But if you look a little bit closer, it is functionally completely useless. If you see the bottom left, you see there's no access to this desk, which is not very useful. So what we came up with, and this is a very powerful idea, which is, let me show the results and then I'll show you. You have different text prompts, and we are not showing the text prompts here. You can create very open-ended scenes, and I'll explain how this works, but it's actually functionally valid, and I'll explain why it's functionally valid. So it creates a layout with objects, instances, etc. So let me walk you through an example. So instead of creating pixels, you really ask for the constraint. So what do we do? Here's a prompt. You ask for a bedroom of a vampire scene. My student was extremely skilled in coming up with this prompt. I would not have come up with this. And then it comes up with, it returns not the final layout, but the functions of it, the different constraints. So you can think of a system in very simple one that returns the constraints rather than the exact layout. And from these constraints, we can create what we call a constraint graph, where each node is an element, like a bed. In the case of a vampire, it's not a bed, it's a coffin, etc. And then relation between them, that they should be facing, away from it, etc. Something that Maneesh mentioned, for many years, we have been working on these neurosymbolic models. With Paul, I see Paul in the audience. So we have been doing it in geometry, we have been doing it in SVG, we have been doing for certain texture patterns, etc. So this is a very nice formulation that allows us to take constraints, explicit and others, and roll it out. So I take these constraints that the system has returned and roll it out into procedure or programs that have some implementations on it, and then you do a constraint solve, and this is the output. So again, to stress, there's two things. The output is not an image. The output is a set of constraints, and then you do a constraint solve, and the constraints are like all the functional constraints, etc. And these LLMs we found are quite good as functional constraints, right? And my biggest test for any interior designer is, does it know the kitchen triangle? How many of you know the kitchen triangle? Okay, so I can say who are the designers in the room and know this. It does know it, so it's quite good. And it knows beyond just knowing it, knows it, which is not surprising, but it sees that. So this is a player GPT part. So now we come to the feedback in this iterative part, and it raises a lot of different questions. And I would talk about this. So yesterday we presented this Monet GPT for image retouching, and some of you may have seen it. So I'll not repeat the talk, but I will again repeat the backstory. So image retouching is a very subtle operation, and it's a very personal operation because I think something that I care about, and I want to slightly change it, but I don't want to change everything, right? And the way this is done, we have developed the community, open source or closed source, many tools for editing these things. And these are really lots of procedure and slider. And this is an example where many creative process is a journey in finding a plan. In robotics, they call it like a planning and etc. But again, the output here is not the final image. The output here will be the procedure or the steps, which is quite an important thing because you can reuse your expertise, right? You can classify this room as image editors for 1 year, 5 year, 10 year, 20 years. If you're like a 10-year bracket for having used Photoshop, you have built certain understanding. And there are two types of understanding. One is a little bit useless, which is how knowing where the lasso is and how to use it. But the other thing is extremely hard, which is building this mental model of what I can do with the thing. This predictive thing. And this is a very key thing. I think Paul will remember many years back, we presented a system here at called Pattern Exploration, PATEX, at SIGGRAPH. And the most humbling thing was a user study where one person said it's extremely cool, very nice, but I would not use it because I cannot predict what it's going to do. Right? So you cannot work with a system where you don't have it. And this experience we have gained over the years is really building a mental model, which may not be correct, but it builds a mental model. So if things change very quickly in terms of tools, this is something we have to fundamentally account for. Let's get to this particular example. So this is this Maneesh GPT, which takes an image and outputs this retouched image, but it doesn't output the image, it outputs the instructions that you have to do. So let's look at this image. So that's an input. What really outputs is a set of operations with sliders, and the operations are restricted to Photoshop or GIMP on which it has been trained. And you can apply it. It's a staged operation. So first it fixes lighting, maybe then color, and then again sharpness. Here are all global operations. But what is super important is a design choice. It comes up with these reasons. Like it tells what was adjusted and why it was adjusted. Being autoregressive, someone can go and change one of them and re-infer for the rest of the steps, which is quite useful. So it really solves these two problems, which is what I call this command knowledge, which is knowing how to use the tool. This is a little bit boring, but sometimes necessary. And I think this part, we are getting closer and closer to automate this. This, I don't think we can automate. This is the strategic knowledge, which is how to do a task, right? So if you do carpentry, I do carpentry myself. All carpenters have more or less the same base tools, but we come up with very different results because we have a different strategic vision for the same task. Right? Of course, they would know how to use a hammer better than I do, but still it's good. So the task is fixed. So in this case, it's all operations. In a bigger scope, if you go really in the neurosymbolic, these operations can also be found, or the library can be found. That we have been working on that space, not what I'm going to talk about here. But most operations are a combination of many of them. So the question we first ask are like multimodal LLMs, can we give them the operations and ask them to only use these operations, which is the first thing you should try, like with the fine tuning. It turned out it gives very reasonable looking results. I say reasonable looking because they look correct, but they are quite generic and hallucinated. Right? So they don't apply this. And the biggest observation here was that they don't know how to identify what are the operations. They don't have the internal model that we talked about. So the main essence of this work is we created certain puzzles, we call them visual puzzles, that talks about planning, and we have a reasoning data set that we could automatically take, so we could make the LLMs aware of these operations. Okay. And as a result, you can get these results. So you see on the right is our result, the middle column is the baseline, the LLM fine-tuned result. Again, both cases, the results of the operations, not the images. In our case, you see they are very subtly changing based on the content. And in the middle column, they all, first you say, oh, wow, but then you say it's always the same slider, same pattern. It's not very useful. This user study, I think we didn't show yesterday, but I think it's an important part and a biggest reassurance here. By experts, we tried it on Lightroom experts with 5 or more years of experience. And you see it's almost at par. I won't look too much into that, it's slightly higher. but it's 50% versus 47% against Google Auto Enhance, right? And these are with all open source tools and designs. So I talked about these three aspects, and we talked about examples, but I want to end with a few notes and some cautionary, and some things that I worry about and really care about, and I hope you have solutions or you would agree with me and you should think about it together. One is I really like these procedural things, and we should have this cycle of discovering the procedures and then also exposing the procedure. So many of you in the audience have done dynamic sliders, dynamic contexts is in that one, but now it's neural procedures also, where the comfy UI is an example. And don't think of pixels, always think of operation. This is the fundamental, sorry, I went the wrong direction. The next one is something I think we underappreciate, which is as humans, and this is again my personal value, we are very bad at doing nonlinear predictions. That's why we make so many bad decisions financially. I do all the time. We are very good with linear decisions. If you have to extrapolate a little bit, that is good. So, but this is the problem. We are building more and more nonlinear tools, which are extremely good, but not good for using as a human, because I don't know how to use it too complex. I think this idea of designing problems to teach LLMs is very tricky and interesting. And I think this is definitely in our domain for those who are in teaching, because that's what we do when we design exercise so that they learn the concept. So that's having a theory would be good. We talked about this multi-turn editing. So the loose control was an example in the box. Then you get something, then you iterate on it, you get better depth and here. Something I hope would come up, but I was completely wrong, was this thing about data ethics. I think this is a problem we cannot just ignore. I see a very uncomfortable scenario where we have a distrust between researchers and creatives, and this is not a healthy scenario. Right? We really have to address it, and we should have methods, and these are not easy problems. Good, it wasn't discussed today. We won't come up with a solution. This will be the biggest success for SIGGRAPH, but I think we just need to have this discussion. Right? Hiding it is not going to help it. And I'll end with reminding you this one lesson I talked about writing papers or drawing figures, that I feel like in the creative process, there is importance of slowing down certain parts, right? How to do that in a useful way, because you don't want to slow down the obvious thing, but you slow down so that it encourages these wow moments. In maths, they call these aha moments, etc. And I don't think there exists any recipe to get to the aha moment without the pain, right? So I think we should embrace the pain there. And with that, I will pause here for any questions, but I know we are tight on time. We should also move on. Thank you for your attention.
We can have maybe one question from the audience.
No questions is usually a good sign or a bad sign.
Yeah, okay, I can go ahead.
I have a question.
Oh, okay.
I love the focus on slowing down because it feels like we're doing exactly the opposite and everything is only speeding up. And so what should slow down and what is okay to speed up in your mind?
I think the exploration part is where it slows down. One thing I have noticed, I don't know, maybe Mira, you know this. I think we are already doing the opposite as you say. So we have these autocomplete, we use it in text and image and others. I think we are taking a solution much more quickly. That's why I think when we have all these notices, we get this email from students and others, and oh, that's AI generative, because you have this auto thing, right? So I think that's an example where we are creating and unintentionally creating a bias in how we choose. But every time we choose, we are doing a data exploration or a creative exploration, and making that so easy has its downside. We should be aware of it. I think we are not aware of it, and these data in fact goes and sort of recycles into new training, and that causes more problems. I think we are amplifying the content in that way. Right? We changed the notion of beauty, which is another very tricky discussion. Same way, so we're doing things without being cautious how we are doing it. Yeah. I think I would refer to those who read Harari, Harari. So I think he made this is amazing thinker that I really follow a lot. So he makes a comment about this generative thing, that this is very tricky, that because it can fundamentally break down our communication system. And so we won't trust. Someone mentioned this before. And this is very dangerous if this happens. I think that's why we should slow down. Yeah. But not in terms of talks, we should move on.
Any other question?
I have a question on like the controllability aspect that in the combination between machine learning and neurosymbolic. I'm just curious about how do you go about the design space for this, because I think a lot of people came to do AI when it was already machine learning, and while others started from neurosymbolic and then saw this transition. So for those of us that came to it already in the machine learning world without much of neurosymbolic, do you have tips or what do you think it can bring to the table? Because a lot of people say you don't need it at all, right? So what is your response to that?
I think short answer is you should read our report on this one. But it is not one or the other, because you can go, once you have a neurosymbolic, that can be a procedure in Photoshop. Once you have a Photoshop operation, you can go back. And there is a human verifier that this is a useful program, because we're trying to find patterns in very limited data, and correlation is not same as causation. So I think there is human verification in there. So it is possible to go back and forth. And so that's how to do it. Thank you.
Thank you.
Thank you, Niloy, and thank you everybody for the questions. All right, so our second speaker will be Jackson Wang from Snap. So pretty cool slides to start. So yeah, take it away.
Okay, yeah, thanks. Okay, so I'll start off by first, thanking the organizers for inviting me here to give a talk, which I title Connecting Through Generation, Identity, Relationships, and Diffusion Models. And so I was invited to give this talk. I was preparing it, and then one day I saw the lineup of speakers, and I was like, okay, wow, what the hell? Everybody else is so famous. And I was like, okay, I'm not very famous, so what should I talk about? So then I decided that I'm going to talk about who I am. And I'm also really going to start from the very beginning. So this is a map around the Pacific Ocean. And I was born on this island known as Taiwan. And I was there until I was about 17 years old. And then my family immigrated to Canada, Toronto, not Vancouver. And as a high school student, I was very fascinated with athletics. I played basketball, and this is me really on the local newspaper. And I thought, okay, cool. It would be really nice if one day I can play in the NBA and then have my own merchandise and become, very famous. And as you can see, that I'm standing here today, and so that's not true. I most of the time work behind a laptop with the company logo lurking in the background. But what's cool about this job, or at least this kind of research that I'm doing, is that at least I can visualize for myself and for all of you what I would look like if Snapchat were a basketball team. Thank you. Okay, so at this point you're like, well, okay, Jackson, this is about identity, about who you want to be, and that's all fun, but what about relationship? So let me tell you another story about myself, and then probably this is going to be the last story about myself. So the best thing that happened to me in the last year is that I have a baby. Thank you. And so I'm super excited about that. And I wish, I can share that joy with my grandmother. Except if you remember this map, so she's still in Taiwan and she's quite old. She's like about 90 years old. And you're like, okay, well, Jackson, why don't you just fly back with your baby? That's easy, right? Except if you know about stuff, as a Taiwanese young man, I would have had to serve in the military. And since I was in Canada and I didn't, that means that if I fly back now with my baby, I'm going to be put behind bars. So that's also not good. And you're like, okay, well, what about some happy ending to your stories? So yeah, because of the kind of research that I do, what I can do is that I can just make an imaginary photo of my baby and his great grandmother. Okay, so enough about my stories, but I hope at this point I've already convinced you that through generations, you can express your identity and maybe deepen the connections with you and your loved ones. And so that's the topic of what I'm going to talk about today, which is what I work on, is the topic known as personalized generation. Okay, so starting from kind of how this all started, personalized generation is really built on this aha moment, as Niloy said, in the emergence of foundational text-to-image model, right? So, 10 years ago, we had GANs and VAEs, and you were able to generate, digits, and you were super excited about that. And then you move on to StyleGAN, but it's still very domain-specific. And then came the fusion models and flow match models. And now these models, they can receive basically a very complicated text prompt that describes a very detailed scene. And then now you get like this image that has really good aesthetics and has all these details that you want. So what is personalization? So personalization is how do we take these models and then make model adaptation? So how can we adapt these models so they now receive image inputs through some image encoders and maybe some adaptation layers to the base model. And then you can get the same images, but with the identities that you want to inject. Okay, and there are many things that are important in the process of personalization. And today I'm going to talk about two. The first one is known as prior preservation, which basically means that the base models are so good at generating all these beautiful images. So when we do the process of personalization, we really want to keep all those good properties. And then the second one is about identity preservation. So when we try to inject someone's appearance, how can we do that in a way that really is faithful to the input images? Okay, so the first research paper that I'm talking about was presented at SIGGRAPH Asia last year, known as MOA, Mixture of Attention for Subject Context Disentanglement in Personalized Image Generation. So at the time, we were working with Stable Diffusion, which has this unit structure and a text encoder. And obviously, we want to add an image input to the system. And as we add this new module, what we need to do is to train it. So we need to train the image encoder, and we need to train the base model as well to work with this new image encoder. And when we talk about training models, well, we need to talk about training data. And so obviously, we need to go out and collect whatever personalization finding data set that we have. So one thing, though, is that usually these foundational models, they're trained in a way that you don't know all the details, you don't have access to the original data set. And so what you're going to see is definitely going to be a distribution shift. So whatever data that you're able to collect is not going to be the same as the model distribution. So why is that important? That is important because as we do this kind of training, there's inherently this personalization and prior trade-off. So the more that we train this model, the more this model deviates away from the prior. So that's good for personalization. That means that your model now has been accustomed to the downstream tasks, but then you lose the prior. So maybe it doesn't follow the prompt as well. And if you don't train enough, then you get really good prior preservation, but then maybe you don't have the ability to really inject the image inputs. What that means is that in practice, you're forced to kind of be somewhere on this trade-off curve. So in this project, the question that we asked is that, well, can we try to break this personalization and prior trade-off? And at the time, and I think that is still true, we're very much motivated by the success in the language model community. They use this mixture of expert architecture that can basically scale the model and have all the different experts do different things. Okay. So we take this inspiration and we change it so that we have an architecture that is known as mixture of attention. We start with the prior attention, that we freeze and don't touch. We make a copy of it that we train, and then we combine these two experts through a router mechanism. And we also train this router. Now, what we want is that we want this router to really be able to specialize in the individual tasks. So we want the prior attention to basically only attend to the parts of the image that are not relevant to the identity injection task. And we want the router to make the personalization attention to only attend to the parts of the image that are relevant for identity injection. So we'll talk about how this is done. And if we dig into this architecture of the personalization attention, we expand it. So we start from the text encoder that we have. We identify the text token that we want to bind the image into. And then we have an image encoder, so some pre-trained encoder like clip. And then you can combine these two tokens and then merge them through a network that we train. And then this network is also conditioned on the position and time-step embedded. Okay, so finally you have this architecture. And what this architecture allows us to do, because of the text and image token binding, is it naturally extends to multiple images as well. So now we're able to do multi-subject generation. So lastly, how do we train this model? We do the typical diffusion denoising loss, and then we have this router loss that we talked about. So basically, we want the router to follow the semantic segmentation map between the foreground and the background. And lastly, we have an object loss that we enforce that each of the text tokens for the different subjects only attend to the subjects they're supposed to attend to. So this router loss prevents interference between the foreground and background, and then the object loss prevents interference between the two different objects. Okay, so next are some experiments. Do we really break this personalization and prior trade-off? So our setup, we obviously have to evaluate the identity fidelity. We also have to evaluate the image quality. We also introduce a new metric. And so this actually turned out to be quite useful that we call a prior score. This was also later used in many of the follow-up works that we do. And then we compare to baselines, and basically the baselines completely fine-tune the model, and they're kind of forced to have this prior personalization trade-off. Okay, and then numbers, that's probably not too important. And so let's look at some qualitative results. So these are the images that we generate from the prior model. And basically the goal is that we want to inject the people. It actually kind of related to what Maneesh was talking about. We want the results to be predictable in a way that we don't modify the image except really just changing the person that's in the image. And so these are the results that we're able to get. And also the same for multiple people. So the goal is that you can really, design the scene that you want the people to be in, and then just inject the people there. And this is also different from face swap because it's not just the face, it's also your body shape, the hair, and also your skin tone and so on. Okay, and then compared to the baselines that did full model fine-tuning, you can see that there's kind of the degradation that you see depending on the data set that you use to train. Okay, and then some application, also again, ControlNet comes up. This is compatible with ControlNet. And the other cool application was that actually you can use it in conjunction with some other editing-based methods. So what you can do is you can take any real image, you can do DDIM inversion to invert it back to the latent code. What's cool here is that it's inversion based on the multimodal prompt. So you actually can use the subject that's in the original image. And then what you can do is you can then swap the person by changing the image input. So this is the result. And then you can do the same for images with more than one person. Okay, and so if you've been kind of paying attention to the images, what probably you realize is that the expression are very much copied from the image input. So actually this deviates away from what we wanted, right? Like we wanted to really preserve the prior. So if the prior describes your expression, you don't want your input image to kind of overwrite that. And then the second is, obviously, we always want to improve the identity preservation. Okay, so in the next part of the talk, before we talked about this adapter layer, so we're going to talk about the image encoder and also, I guess, the adapter as well. This was a paper that we presented at SIGGRAPH earlier this year called OmniID, a holistic identity representation design for generative tasks. So the motivation, actually, this is, maybe if one thing I want you to take away with today, other than my life story, is this one. So an image is worth 1,000 words, but maybe 1,000 words is too many, right? Because an image actually has all these attributes. It's your identity, but also the background, and also actually the pose and the expression. And when you do the common single image adapter training, everything is learned, right? So like the image has the identity information. Maybe you can say, okay, I can remove the background information by using segmentation. But what about expression and pose? I mean, that's intrinsically coupled with the image. And because of that, your image will actually override your expression. So like this is kind of the copy paste degrades the expressivity problem. So if this is the image that's generated that you wanted to generate, so the main with the starting expression, and then your input image actually looks like this, where he has a very neutral expression, then what you're going to get with the previous method is that the expression is really going to come from the input image instead of the text prompt. But then in the desired output is that you really want the model to be able to follow the prior expression. So the problem was that, okay, everything comes from this single image training. So maybe one idea is to not do that. If we can have access to a set of images that features the same vector, then the only common denominator would be their identity, but not their expression. So then if we can use an input image that is different from the target that we're trying to reconstruct, then maybe we can do better. We can learn a cleaner representation. So this is the idea. Also, this is very much related to the advances in 3D models, where you have multiple views of the same structure, in this case, the same person. What we can do is this few-to-many encoder training, where you use a few images from the set of images as input, and then how you want to reconstruct all the different views. And then if we expand into this OmniID encoder, it's basically a simple Q-format structure that's based on pre-existing encoder like clip, and then you're able to merge all the input information into this fixed representation. And then we'll train this encoder. So this is without the OmniID representation. You have the single image input, you have the single image reconstruction task. With OmniID training, we have multiple image input, and we're also training the image encoder. And if you directly use this for diffusion model training, then the training is difficult. So what we introduce is a stage-wise training, where we use a pre-training task that's based on masked auto-encoding, and then we go through the diffusion model training. Okay, and then some results. So if we look at this input, at the top row is the results from a single image. At the bottom row are the results with two different images. If we look at pre-existing encoder structures like Arctic and clip, you can see that this guy has this like ego beak nose feature that is lost. And even if you incorporate more images, not only that it doesn't have that, it actually gets worse because these encoders were not designed to work with multiple images. And with OmniID, in the one single image case, that still doesn't work out because in the front view, you cannot see the structure of the nose, but in the multiple image case, then you can see that. And the other results is that the comparison in the controllable generation setting, with arc face, you can see the inconsistency when we do the pose and expression manipulation. And then with clip, you can see that it introduces some artifacts. And with our representation, we don't have either of those problems. And then last result, kind of we see the same effect in the personalized generation set. Okay, so to conclude, I think also this came up in the panel discussion earlier. There's like advances in the multimodal models, but I hope that today you still learned that no matter how the models improve, so when we think about model adaptation, we need to think about how can we prevent distribution shift, and also how can we learn specialized representations through cross-reference training. Okay, and then the last thing is that if you're like me and you have this fantasy of seeing yourself in different situations, then you can go to this website, studio.snapchat.com, and then you can say, generate the kind of prompt-based things. And here I say, okay, generate Jackson as a media player. And what's also fun about this website is that it's integrated with all the other tools that we have at Snapchat. So then you can say, well, why can't I make a merchandise of myself as a media player? And so let's see, it's generating a lens. And then you can see me wearing a cap that features myself as a media player. And just like any other normal person, after you do that, you force your friends to wear that cap as well. And that's it. Thank you.
Thanks, Jackson, for the great talk and also the great demo. So do you have any question? I think we have time for one question. Yeah.
Given your loss on like the photorealistic output and the photorealistic input, did you ever test how it handled like stylized versions, like the anime version?
Yeah. So that's a great question. We do, and in fact, if you use Snapchat, there's all these lenses. They're in stylized generation. They're all based on the same technology. And in the last month, we had a Labubu lens that was very popular.
I think we can leave more questions to the panel discussion. So thanks, Jackson, for this great talk. All right, so let's welcome our last speaker, Professor Huamin Qu. He is the main driving force of visualization, HCI, and also graphics, and also like a lot of like interdisciplinary studies between art and the technologies. He also found like the Academia of Interdisciplinary Studies is the founding dean of this new schools in Hong Kong, USD. So without further ado, so let's welcome Professor Huamin Qu for this great talk.
So I think after Jackson's very humorous presentation, I feel my talk will be a little bit dry, but I can make it short, okay? So I come from different background. I work on this kind of data visualization. So when I received the invitation, actually a little bit hesitate, but I look at the workshop, the goal is called a cross-disciplinary platform. That's convinced me. So I think it's maybe I talk about the research problem from our field, and maybe can persuade some of you to join us to solve our problem. So I lead this called the VisLab, and when you work on the data AI, sometimes you need an interface to interact with. That the interface is usually the visualization. So it's a big lab with more than 70 graduate and ongoing PhD. So we work on many different things, but the one thing is called the data storytelling. So what is the data storytelling? A classic example is called Hans Rosling's this talk and the TED Talk. So he just used 4 minutes to explain 200 years human history on economic development, life expectation. So this one already viewed 10 million times. I mean, I checked last time on YouTube. So you will see more and more this kind of short video and emerge in this social media. And they use millions, tens of millions times. They explain what is the trade war, what is like, I mean, this virus, all these kind of things. And those kind of video, and from SIGGRAPH point of view, their imagery is not that impressive, but they tell some interesting story, especially when you want to communicate some key decisions for education. That is still, I mean, they got a lot of attention. So, but once again, so it's still at a very preliminary stage. So what is the data storytelling? And this is one definition. So you just try to leverage the art of visual and the narrative to make the data communication called understandable, engaging, and enlightened. So this is the 3 goals, and you basically need this kind of visual and the narrative things and to make the story just like the normal story, right? So this is some kind of research goal, and for this data storytelling, first you need to understand what is considered good data storytelling, and then you come out with some kind of guideline. For this part, we still heavily use this called human-computer interaction methodology. So what we do is we got good examples. One use human to do encoding, and then basically to cluster, then bottom up to build up this kind of guideline. So far, generative AI doesn't help much, I mean, in this part. But second goal is just empower human to achieve efficient and effective data storytelling. In this part, AI already play a lot of roles here. So this one we said, okay, you got the data, then you use, different tools, AI tools, visualization, whatever, to get data insight. Now you already have a data insight, but how you convey this insight to the audience, right? This is called, you need some kind of way strategy, right? So actually, the SIGGRAPH, this opening, the session, it talk about this year SIGGRAPH got 900 submissions. Then the key is about AI. Then you think about there are a lot of this kind of the scenario. Then you want to present some kind of data, but the way is still very dry. You just show some kind of chart. You directly through this kind of the conclusion, right? There are no setting, no climate, no resolution. It's not something we expect for data storytelling, right? So that one actually shows as an example, as a bad example. Maybe in the future we'll see more and more this kind of good example come out. When we convey this kind of data and insight to the audience. So the second part, this part actually the AI help a lot. So once you have data insight, you figure out how you want to do it, but also still details, design decisions you need to come out with. So then how can you get the efficient creation of data storytelling? Then how you can unleash the creativity in this kind of data storytelling, right? These are two key words. First, if you have a data story, you want to get it, for example, I only have 30 minutes, then I want to get a video in one minute, and then you can actually convey the message. And also you want to come up with different style, different creativity, and to make it more engaging, right? So this is our research framework. So the bottom one is more about, we said, what is good storytelling? And this one is come out from, we collect many good examples, and do human encoded and come up with guidelines. If I have time, I can briefly show something on this part. The second part is called the data insight. Then you want to make it functional, make sure message conveyed, and you want to make it engaging and artistic, then with the help of AI. So this is something we talk about. So then, okay, the one key research problem is how can AI help in efficient and creative data storytelling creation? So this is a paper from last year's CHI, and actually we addressed this problem, and we got this best paper honorable mention. So because I think the topic is timely, and also I think the citation is good. So we said, okay, now we look at this kind of a different called the data GIF, different data story, and how this actually this kind of a data animation, data GIF, data story, how they crafted. And then, okay, this is something we want to understand. There is more examples. So that means in high community, people already publish some kind of results, and this results and looks, is one step further. But how this results is crafted, and it's by AI, by human, and what is different role played by AI and human? This is something we want to answer. So this is we will do a comprehensive survey and to answer the questions. So where are we so far, right? And then we actually collect more than 60 tools published between 2010 to 2023 in this top HCI and visualization venue. And then we try to understand, just like question answered, how AI, human play different role to craft this kind of results. So what is our key findings is, first we said, when you want to get a very impressive and data storytelling, what's a different stage? We said the pipeline is like this, you first need to analyze, right? To get what is the data insight. Then you want to planning, okay, basically you use what kind of structure and visual to tell the story. And then you need to implement, and eventually you want to generate like a 30-second, 5 minutes video. Then finally you want to communicate, right, this one to the audience. So this is the fourth stage about the data storytelling. Then among the fourth stage, the next question is what is AI and human? What is the role played by AI and human? So we basically say when you craft the effective data storytelling, the role by human AI is actually have 4 different kind of role. One is the creator, the second is called assistant, then is optimizer, and then the fourth role is a reviewer. So based on this kind of taxonomy, and then we actually the survey is 60 different tools. Then this is our finding, right? So basically say, and you can see just like in different stage, like in this kind of just like the analysis stage. Usually just a human is a creator. Human decide what kind of things we want, what story we want to create. But with, the AI actually as assistant, they basically help you to do data processing, prediction, something like that, right? So if in this kind of implementation stage, then the human is actually an optimizer that just gives some kind of a hint. Then the AI can play a creator role, actually is how to actually design, how to implement this kind of structure and data storytelling. And then, okay, what is the trend so far, right? So this is actually the most interesting finding from our, the study. So at 2018, and there are 7 different tools. It's all the human play the creator tool. Human decide how to tell a story. AI just help, okay, do this kind of implementation and something like that. And then, okay, in the 2019, and there are about 19 tools. Then the people feel very excited by the AI. Okay, we just give some prompt, whatever, like AI. Okay, actually play the creator role. We said this is the data, generate some kind of visualization to convey to the audience, then leave it to AI to come up with these things. But it's clearly cannot. It's done the work, and now the recent trend is 2023. The 17 different tools. Basically, we go to the stage called a mixed creator, and the human AI both play this creator role. So this is actually the most interesting part. So then we said, okay, this is the current structure, and then we craft this rule and the data story. And so with this, the workshop was more about the generative AI. So we actually also do some kind of work to unleash the creativity and to make the video more, engaging. So this is our paper published in WIST and 2023 is one of the most discussed paper in China social media for this kind of WIST paper. So because demo is pretty cool. So the idea is we have a long line research try to use the text. So text is non-communication, right? To make the text more impressive. So how to make the text to convey different emotion, right? You can show a static text. But also you can use the text to convey this emotion, like I'm happy, I'm angry, I feel uncertain, something like that. So this is the way, okay, we said, okay, for this generative AI, usually one key issue is how you understand the user's intent, right? So this user's intent, sometimes the intent is hard to describe. Then we use more like this kind of transfer learning. And whatever, you just show me some kind of cartoon, and that can generate a text. Just move just like your cartoon, right? So this shows some kind of demo. So the top line is some kind of cartoon input by user. The bottom line is we can make the text, just the animation is like that kind of cartoon. So this is just like making the demo, and this paper is called the Wiki. And the demo, you see this kind of things, and dramatically improve the efficiency. In the past, if a human want to do this, and you use this is just one very simple, but you got some more complex example. The AI can greatly improve the efficiency, right? So another work is just like we further down, and not just make this kind of text, the motion is convey something. How about this text convey something else? How make the text make it more romantic and makes more expressive? So this is our paper published in SCCV, collaborate with my academic brother, Daniel Kuan-Chieh. So I think I can know all the tech details. So this paper, I feel is there is a demo. I can see this is actually how this kind of generative AI can unleash the creativity. So this also got a lot of I just play this video. So romantic, right? You see how this kind of passion. This is love, and this is the father. Yeah, this is a long video. I think it's all example we put on our website. I think it's really fun to work with. So this one, you see, this is indeed this generative AI greatly improve the expressiveness of this the text, right? So let's talk about okay, we said okay, this is the general AI part, and another part we use is called the human computer interaction methodology to come out what is a good strategy to derive this guideline to craft the good story, data story. So we said what is structure of the story, and the story have a start, opening, have a beginning and middle and end. Then we indeed actually start to study what is actually considered good opening, what is considered good ending, and what is how to make the structure and more. I mean, just like follow this kind of the classic or the film example. So we have this kind of opening and climax and ending. So I just briefly talk about this kind of methodology. Right? This is a classic theory from film. Then every movie you have some kind of setting. Then you have rising, you go to climax, then you actually go to the resolution, right? Have a takeaway message. So how we study this problem? We collect more than 103 data videos and have this kind of structure. Then we actually use human different researchers to encode the structure and to come up with some kind of guideline. And after this kind of guideline, how to prove this guideline indeed effective, right? So we run a workshop. We give this kind of guideline to audience, then ask them to craft some kind of data story and follow this guideline. Then we compare, right? We can do this kind of compare with another group without this guideline and see whether this one indeed become more impressive or not, right? So I think it's indeed actually is works. So we actually publish a lot of this kind of paper along this line of research. So because of limited time, so I basically just skip all the details. So once again, this is still very early stage. You see a lot of scenario, the story involving data still talk in a very dry and uninteresting way. Just directly tell the message, no setting, no climax, and no resolution. And also the imagery, the visual is very primitive, just a bar chart, right? Just these kind of things. I feel there is a lot of opportunity there to make that part of everyday experience, right? We see this kind of story involving data, make that story more cinematic, more artistic, and more memorable. So this is some paper we published in different venues, and one is a guideline, another two. In the two part, we also heavily use generative AI tools. So this is our website, and I have all these kind of papers, and we collect there. So if you're interested, you can go to our website and look at the paper. And also I make some advertisement. In our university, recently we established two new divisions. One is called the Division of Computational Media and Arts, and another division called the Division of Arts and Machine Creativity. So altogether, we have about 40 faculty line, and there is plenty of opportunity on this domain. We heavily recruiting. So if you're interested, you can actually try to we really want you to join us. So this year, I think we are actually pretty strong in this SIGGRAPH arts paper. Among 17 arts paper, 5 from us, 30% is actually from these two divisions. So you look at the focus of this division, machine creativity, machine assistant art practice is all heavily related to the same workshop. And one organizer, Annie, just joined us last year, so I hope we can get more. So, okay, thank you for giving me the opportunity to talk about the research problem and the current results from our domain, and hope more can join us to work on this very emerging new blue ocean problems. Thank you.
Thank you, Professor Qu, for the great talk. So if there is any question, you may raise your hands. Question. And then we can also set up for the panel discussion. Also discuss the panel. Yeah. All right. I think me and Fabian will host the panel. Yeah. And yeah, that's.
I also graduated.
Right, so okay, so now we're gonna have the panel discussion. So Feel free to, we're gonna start with some questions, but if you have any questions in mind, keep it there, you can ask it at the end. So yeah, we wanted to make this panel a little bit more interactive.
Yeah, I think I may start from the some introduction. So I wanted to ask the panel, could you please again, briefly self-introduce yourself and why you are working on generative AI?
I'm Jackson Wang, and I now lead the personalization Gen AI team at Snapchat. And why am I working on Gen AI? I guess I try to show that a little bit in the talk today because I believe that's a way to make people who are not artistic like myself create art quickly, and then through that share love and connections with others.
Hi, I'm Niloy Mitra. I am a professor at University College London, UCL, not UCLA. And I also lead the Adobe Research London group. I work on this topic because this seems to be the only one that interests students and funding. But I think more seriously, this is also the topic where I think I care about creativity and how we generate. So if we don't understand it and we don't develop it, it will take a form that I may not like. So I try to do that.
Yeah, I'm Huamin Qu. I'm a dean of this called the Academy of Interdisciplinary Studies at HST and also chair professor in computer science. So my main research area is data visualization and human computing interaction. And so why I'm interested in general AI, you think about this kind of a lot of a story related to the data, right? Whatever the SIGGRAPH, 30, 40 years in evolution about SIGGRAPH, and also our personal story, right? And it's not just imagery, a lot of things are personal related to the data. But not all this kind of stories is told in a terrible way. And it's just like, you don't have actually this kind of tools, right? To help you craft very impressive, just full of this kind of imagery and just like go to this artistic level. So that's why I feel this general AI give us hope, and we can dramatically improve this, artistic, the data storytelling, and give the tool to everyday people, to ordinary people.
Yes, again, if you have any question, you can just raise up your hands. Otherwise, I think I will follow some question. Oh yeah, yes.
So again, this is the question. So with generative AI, I've seen some problems and some limitations that are actually coming. I just wanted to know your guys' opinion on it. So we had the fingers problem that was there, which is, I think so, primarily fixed now. But I still see the problem in perspective and shadows. Is there anything that's happening? I just want to know.
Since the mic is in front of me, I'll just start. Yeah, so I think the quality of these AI generations has improved a lot. And even in my talk, there was a mixed bag of results because it's crazy. Even the paper that I showed with Boa, that was based on SD 1.5. So the result wasn't the best. But then in the intro, the stories about myself, I was using our latest models that kind of integrated, all the different advances in the last year. And then the quality has improved drastically. And specifically with 3D and physical kind of fidelity, I think I'll answer it at a broader level. So I think what's happening is that all these foundational models, they can do a lot after pre-training, but then those models don't typically generate very high quality and good-looking stuff. So then they go through the post-training stage. And depending on what data you use for post-training, you get very different aesthetics, and you have a model that are good at different things. So I guess to answer your question, I feel like if some models or some company or some people who are super serious about this, you take a pre-trained model and you fine-tune on data, they're super physically plausible and 3D consistent, then you probably would be able to do that pretty well, especially given the larger models today. but then you probably, the same model probably wouldn't be able to do other things well. So like, for example, maybe you wouldn't be able to create crazy 2D arts. So I think there's some trade-offs there.
I would give a slightly different perspective, maybe a more pessimistic view of the world. The one solution that works, and it's not my statement, it's Sutton's statement. You may have heard about the written lesson of life in ML, which is the one way that really works is more data and more compute. But I think this is because we hope for the best that this would work. But the main problem is it's not like an algorithm where we compute like complexity and all that, right? And I think this is a problem I face even now when we develop a method, even when I review, and I don't know how many of you share this, that I look at a paper, and each paper also comes with a story. Like, this is what happened, and this is what it reacted. I don't think this is entirely true. I don't think we are being honest. There are papers we have done where the results speak for themselves. But if you ask me, what is this key thing? I have a speculation, but it may not be the real reason. It may be the data set got better, right? Or I had more compute at that. I think that's researcher-wise, we need more tools so that we can actually study and relate like cause and effect directly, because then we can improve in a systematic way. But I feel like it's moving so fast, we haven't developed those tools yet.
Yeah, for us, I think the major issue is this kind of high quality data related to like visualization, data storytelling. It's still, not many. For example, the example I showed only just 100 whatever. If you use this kind of AI tools and this is a 30-year SIGGRAPH summation and the theme and the sessions and authors, then tell me a good story. Generate a 31-second video. And it still doesn't work. So I think Microsoft introduces Copilot, and that is actually integrate the different things together, improve the efficiency, but far from solving this problem. So I think it's we get help from AI, but we don't feel actually threatened by AI at this stage because we don't see much good example come out from generative AI.
I also will make a short comment on the finger thing. It's not like it fixed because it now makes people with 5 fingers, but if you ask of a hand with 6, it can't do it anymore. So you lost the multiple fingers, which were kind of cool depending on what you want to do. But my question to the panel is on the customization efforts. So I think each different, I think all of you are working customization on different domains. And my question is on kind of this, like, I think human faces specifically, it has been shown that it's something that is really hard that these models will learn on their own just by scaling, right? We keep building bigger and bigger models, and you still need these adapters to kind of do a zero-shot facial customization. But we know it's theoretically possible because famous people in the data set ends up having their face, if you just prompt their names, the face works, right? So do you think this is an architectural challenge or this is a scaling challenge that these models don't learn facial features or other customization aspects like or the dynamics that you need the neurosymbolic systems to give consistency, or the processes for animation? So yeah, overall for the panel, do you think customization is a challenge of architecture or a challenge of scale?
Okay, yeah, I'll start. I have so many comments because that's literally what I think about. Probably almost the only thing I think about. I wanted to start by also kind of echoing back to the work on Omni-IP. So like, when we talk about like zero shot and single image customization, say for the faces, like that was like also the example with like the ego beak type shape, right? So like from a single view, like you just don't have information about what you look like in other views, and also everybody have their own different expressions, the way they walk even, and so on. And actually that changes all the time. Like if we should think about humans more as like avatar, like a more holistic representation. It's about you under all different scenarios. And even that changes, like the way I wake up every morning, I look a little bit different. And so that's the first comment. I don't think a model that takes in a single image will solve appearance injection ever, just because the information is not there. Now, if we think about would there be, like, would customization remain to be a problem in the future as like the models become better and better? I don't know, it's hard to say. Like maybe GPT final, like the final version of GPT will just consume all the tokens, including videos and images and text, and then follow instruction and do stuff. On the other hand, when we think about humans, like I'm specialized in computer science, and there are people in the audience who are specialized in art, and so even though we are generalists, hopefully we are kind of like GPT final, we still need to be customized. As humans, we are customized. And so I think, yeah, maybe customization will always be a problem, but not so much in the adaptation of models, but actually designing reward functions and designing those things, adding controls, and then how to align the models to those special needs.
So the reason I like working in neurosymbolic, it's very restricted in the sense you come up with symbols, you come up with programs, you can look at this and you can see if it makes sense by generation and other things. But it's also very restricted in the sense it can't do any image, for example, because it's constrained by the procedure it's found. Now, I think in generally, this is a big topic in visual computing. Generally, like as soon as we can define a metric, we have very good tools now to optimize. But the most basic questions we need in visual computing, is it a good image, like aesthetic score? You'd see many papers trying aesthetic score. The best we have is ellipse now and some variants of that. I think this is a fundamental question, which is a little bit for identity also. In some way, for those who know me long enough and know Niloy as a researcher 20 years back versus now, you might think it's a different person, right? Even if visually I might look similar, except for the color of the hair. But I think that we haven't defined what we mean by identity. Like, what does it mean to preserve identity? We are throwing some examples of it. And we expect it to learn, even the example that Jackson showed, like 4 images, it has to learn, it being whatever the model, that the garment change doesn't matter, the lighting doesn't matter. This is like, it's just imposed, right? You cannot mathematically write it, right? So I think we cannot formulate it in a reasonable way, but it's an impossible problem. So we try to come up with approximations to the problem. But the fundamental problem is we don't have the absolute optimization to write, even if it's unfeasible, because then we can agree what is identity. I think if you ask here, I don't think we would agree even what is identity. Forget about preserving it.
I think for us, the challenge is different. So we feel this currently is always kind of foundation model, whatever to help we understand the natural language, the human, and the natural scene. But for this visualization, human generated abstract is kind of the visualization form. And indeed is different. And actually in our field, we have to twist and our data and try to fit in the model and then try to. And so it's a very simple task. You give us through a visualization said whether this visualization misleading or not. And the answer usually is often not reliable. We have to decompose and do a lot of customization and to decompose and to address these simple questions.
Sorry, I have to say something because identity is something I think about a bit too much. And also because like Mira was talking about the video that you made for your daughter, and then she was like, oh, that's not me. And, like that, I think about that a lot because it's exactly what Niloy just says. Like, what is identity? Like, I suspect, like, no matter how, even when I look at some of the images that I generate by myself, I feel like the human brains, you go through a process where you're like, you try to retrieve it from your memory. You're like, have I been there before? And then you're like, oh, I have not been there before. So you're actually not judging identity by your face or how you look. You're actually judging identity by the actual experience that you had.
And so I feel like, yeah, identity is also potentially more than just how you appear, and that's kind of crazy.
I'll add just one more thing, which is in my video, the little character did not look at all like my daughter, and that was not my intention, but the story I was trying to tell was so familiar that she should have recognized herself, but she couldn't because my storytelling skills are poor. But so, that's another part of identity, which is it's not just the visuals, it's about what we're doing and this experience we had.
Yeah. Yeah, you can still.
Oh, okay. I have a question for the panelists and also for Mira and Maneesh to be channel. So today I heard a lot about like abstraction and mental model, and I'm very curious to hear. I have a question. So lots of each of you working in a domain with like high dimensional creative workflow, whether easily block out in visual authoring or identity generation or structuring complex stories, or even video editing. So in all these cases, do you think a chat interface the right abstraction for guiding the generative system through exploration, refinement, and feedback? Or I guess like, do you notice any other type of effective abstraction for mental model that would help users in these kind of tasks?
I thought you would start with Maneesh because he was just. So you asked two parts. I heard two things. So one is like high dimensional data. And again, this is because I work in geometry. High dimensional data, anything beyond 2 is hard. So I think we're very lucky that we are two-dimensional creature because we walk. A bird already is there. So if you know about like random walk, two dimension and 3 dimension, the results are entirely different. So you can't, any intuition we have developed, the best thing you can do, high dimension, you can throw that away and just follow the data. So this is one part. What was the other question?
Like most of these interfaces have like a chat box that you just type in.
Yes, yeah. The single. I think that's something can say. The current version, I think it's no, it's not an answer. But text is extremely powerful, much more powerful than I thought 2 years back. When I first thought like text to image, this is a crazy talk. So it's good that we were shown that we're completely wrong. But what we are seeing now is this multi-modal approaches, which is this ability to go between media, like from text, you get to an image, from image, you get to depth, you get to 3D, you rotate it. I think this is good. This is something we can track. It may be that the next version of whichever is the next biggest model, it will prove us that even that is not necessary. But the current speculation, and this is also drives when we do research, is this ability to go between the media. So you don't think of a one-turn generation, but I try to say this multi-turn. Maneesh talked about the consistency, etc. To have it and the ability to now prescribe something else. Like I like that, but the color is different. I like that rotate angle. So one was an image example, another is like a 3D example. It's very popular mic.
You want to say chime in or?
Sure. Yeah, I think this second question about chat as the interface, to me, the question is not so much about what the surface of the interface looks like. Almost certainly we need more than text. ControlNet uses more than text, for example, but for visual things, we almost certainly need more than text. I think the question that I think is of most interest to me is how can we have the machine understand the relevant concepts that are relevant to the intentions of the user. So the neurosymbolic approach is interesting, and I presented that a bit at the end. mostly because you can start to embed relevant concepts in the code and the grammar that you provide systems.
Like to make another point or a warning in some way, because there is another aspect which is what we had talked about, the mental model, right? And in many tasks, we don't know our mental model. We can solve the task, but if you ask me how we get to the solution, I cannot be articulate. I may be telling this is I think, but it may not be really how it works. That's one thing. The other thing, I feel these models, and we have, this is, I think I'm more confident now, like text to image or text to video, it can do with an update everything. But the problem is it will come up with its mental model, its structure. So it is in unguided sense, it can generate everything, but we cannot develop something that also somehow aligns to the human one so that we can control it. So you can have a genie in that case that does everything, but I can't tell it which one to do. So that's another challenge we have, that these two internal states have to be aligned, or we will be able to have an adapter that can reach it. What we have now is a very constrained adapter that reaches only a small fraction of what it can do.
I do have a follow-up on this. We're seeing that potentially the technical career of entering like digital artistry is becoming lower and lower, right? So how do you think digital artistry will evolve in the future? And what responsibility do we have as AI researchers into communicating that into academia, academia in the art form, right? Like, how do we actually communicate what's going to be the new tools people will be using? Yeah, any thoughts around this? Is like, what should we do from our AI researcher hat to actually influence how new generations of artists will form themselves?
I think like making them available, right? So open source is a great solution, others. But at some point, we have to also work out the economy so that people who develop them get paid, students who develop them get paid. But that's a different question. I feel like this tooling will come up, like new and new tools will come, and people will experiment with this, and that's good this way. And if I wish, like I presented something like here's maybe this is important for those in the audience as students or early researchers. You come to this talk, you listen to my talk. Oh, this is like three pillars. Like you have these structures. This is not how research works. We did all these things. It's very chaotic. I solved this, and then in the process, I realized, oh, there is this structure. This is what I was really trying to do, but I don't know the structure to start with. So I'm saying with the tools, I think it's important people to try out the tools. That's why I really like this talk, because you could see how people, I did not think of how they would use it, and they use it. And once you see it, okay, I get an idea. Oh, I can do this like brush that would do ice, or I can do the brush that would do these weeds on the building. Right? So these were very going back and forth. That's why it's important to have the conversation going between researchers and creative artists, which is something I mentioned in my talk, that I think we have a distrust which is not good for research and the creative process.
So you see, we established these two new divisions, and we put artists and also art background faculty and also tech background faculty together and do something. So I remember when we tried to establish a new division called Arts and Machine Creativity, we do a survey about the name. And many people say, oh, to call future arts or new arts. But you want arts and machine creativity, machine creativity is especially provocative. And the faculty from humanity, from arts strongly against it. And no, machine have no creativity. If you ask them what is generative AI, always AI just learn what already happened. They have actually no idea what the deep learning works. So there is a survey by, I don't know, Focus or whatever, it said, okay, about this kind of AI, the people from tech background usually positive, from economic background is neutral, but from humanity is actually the pretty, the conservative. So I think that's why we established the division, put them work together, and they gradually understand, right? And from both sides, why they have concern and what is actually the frontier of technology and why something creativity come out from this generative AI instead of what they thought. It's just a search, it's always kind of thing what happened. So I think is this two new division. I feel very good on the experiment. I think is we already show some kind of early success.
Maybe the last question, but I mean, you're gonna skip a.
Yeah, it was just a quick comment because of the art question and the last one that I wanted to say also that usually it's good to think that artists, like you can split artists in like two big categories, which is like applied arts, which is like in design and all, like you apply your arts to a craft, and then pure or like fine arts, which is just doing art for the art, like in a museum or a gallery. And I think that the fine arts people are either indifferent or very excited about AI. Some of them are using it as a tool. I work with a lot of them. And some of the applied arts are the ones that are a bit anxious and concerned. But in part, I think there's just really quickly, there's a three-part thing there. One, some of them are concerned because of the ethics, like how are these models trained, were the artists fairly compensated, and those would be fine if they know that the data set is like fully licensed, or if it was trained only on public domain works and all this stuff. The other hand, there are the ones that are concerned about their employment. So it's more of an economic question, like how do we sustain a world where this becomes the norm? And then I think it's more of a public policy answer than like whether the AI community can answer. And the third ones are the ones that are really think that this tool is not great for like the human creative expression, which I think is a fair and honest position. And then for those, I think there will be those organic kind of AI labs that you mentioned that tool. So I think we have a three-way process with different answers on each, but yeah, just to add to it.
For the comment, and thank you to the speakers and the panelists. Thank you so much for coming, and thank you everybody.
Let's thank the organizers.
Yeah, special thanks to Or and Goda. I think they were like all sort of the